Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is the first class about domain of a function. I saw many students, they feel difficult to understand domain of a function. I just want to do at least 50 to 60 problems in this series of domain of a function. So this class is all about all basics. What is domain? How to calculate domain of a function. Some small problems we will do in this class. What is domain of a function? That's what we will learn first. As per the textbook, the definition is like this. I taken a function f from a to b is a function. Then this a is there now. This a is called domain of that function. If f from a to b is a function, then a is called domain. What is this b? B is called codomain. If f from a to b is a function, a is called domain, b is called codomain. And what is range? Here f of a means set of all images of set A. I will tell you in an example, you will come to know what is range. F of a is called range of f. F of a is called range of f. You observe this example. Is this example is a function? You observe what is function? For every element in set A, there exists only one element in set B. That is the definition of a function. Here, for the element 4, there doesn't exist any element. Is it a function? It is not a function. If it is not a function, there is no question of domain. If it is not a function, there is no question of domain of a function. Okay. You observe this one. The element 4 is mapped to D. Now, the point is it is a function? How to know whether it is a function or not? In simple words, every element of first set is used. It is used only once, right? Every element of first set is used. Yes, this is used, this is used, this is used, this is used. Every element is used. It is used only once. See, 1 is used only once, 2 is used only once, 3 is used. Suppose it is like this. Here you see 3 is used twice. Is it a function? No, it is not a function. So to check this, whether this is a function or not, every element of first set is used. It is used only once. Now here every element is used. It is used only once. So this is a function. Now in this, what is domain? In this example, what is domain? Yes, answer, what is domain? If f from a to b is a function, a is called domain, I said na. So what is the domain of this function? This is a function or not? F from a to b is a function or not? Yes, it is a function. What is domain? A is called domain. This set is called domain. What is domain here? Domain is 1, 2, 3, 4. Very simple, right? Now, codomain. If f from a to b is a function, then b is called codomain. Set B. What is codomain here? Codomain. A, B, C, D, E. Set B. Set B is called codomain. What is range? What is range? Range is nothing but f of a. F of a means set of all images of set A. Here I will explain what is image. If f from a to b is a function, then image of 1 is C. You see here 1 is related to C na? Image of 1 is C. Image of 2 is A. Image of 3 is B. Image of 4 is D. You understand what is image of 3? Image of 3 is B. What is image of 4? Image of 4 is D. Similarly, pre-image. What is pre-image? What is pre-image of A? Pre-image of A is 2. Pre-image of B? Pre-image of B is 3. Pre-image of D? Pre-image of D is 4. And what is pre-image of E? What is pre-image of E? There is no pre-image for E. Understand? There is no pre-image for E. Okay. Here what we need to find? Range. What is range? Set of all images of domain set. F of A. F of A means what? F of A means what? Set of all images of A. Okay. Images of A. What is range? Set of all images of A. Okay. Image of 1. C. Okay. Image of 1 is C. Image of 2. A. Okay. Image of 3 is B. Okay. Image of 4 is D. You observe the difference between codomain and range. Codomain is this full set. But when it comes to range, the elements which are having image, see A, B, C, D. A, B, C, D. E is not there. I hope you understand. This is the general thing you need to know about domain, codomain, range. Now, I am going to explain few problems. Completely, I'll discuss domain only. I'm not going to discuss range also. I'll discuss domain only. This series of all videos are all about domain of a function. I just want to do at least 60 problems on domain of a function. I always do from easy to difficult. Okay. You see here, I consider a function f of x. F of x is 1 by x. What is domain of this function? What is domain of this function? Earlier, it is in the form of a circles map diagram. So we can easily say what is domain, codomain, range. For this function, what is domain? Simple words. For what values of x the function is defined, that is called domain of the function. For what values of x the function is defined, that is called domain of the function. I'll suppose this is a real numbers to real number, and what is the function here? F of x is 1 by x. For example, I'll take some numbers here, 1. Here, what is the function here? Function is 1 by x. What is domain? For what values of x the function is defined, that is called domain of the function. You keep this point in your mind. For what values of x the function is defined, that is called domain of the function. For example, this is the real number set. I take x equal to 1 by 2. What is x here? What is f of x? F of x is 1 by x. When I take x is 1 by 2, what is f of 1 by 2? F of 1 by 2 is 1 divided by 1 by 2, which is same as 2. So, this is mapped to 2. 2 is there now in this. Real numbers, you know, all real numbers, all the numbers in between minus infinity to plus infinity are known as real numbers. Okay, now f of 1. What is f of 1? F of 1 is 1 divided by 1, that is 1. 1 will be there here. F of minus 2. What is f of minus 2? F of minus 2 is 1 divided by minus 2, that is minus 1 by 2. Minus 1 by 2 will be there for this. It will be like this. That means for all these values, respective value exists. What is the definition of function? For every element here, there exists, for every element in first set, there exists only one element in this set now. So here, when I take x is 0, f of 0, what is f of 0? F of 0 is 1 by 0. What is 1 by 0? 1 by 0 is not defined. You know what is 1 by 0 value? 1 by 0 is infinity. Infinity means not defined. Nobody knows what is its value. So, when I take x is 0, what value for this value? What value exists here? Not defined. F of 0 is not defined. Try to understand. Can I take domain of this function as all real numbers? Can I take domain of this function as all real numbers? No, I cannot take. I cannot take 0. Other than 0, you take any number. Suppose you take 1 crore. What is 1 crore? If I take 1 crore here, what is f of 1 crore? 1 divided by 1 crore. That is a real number. There exists here. I hope you are understanding what I am saying. What is domain of a function? For what values of x the function is defined, that is called domain of the function. Here, what is the domain of this function? Domain of this function is all real numbers except 0. You cannot take 0. Why? When you take 0, what is f of 0? F of 0 is not defined. So, from now onwards, I am going to specify this point only. Whenever they will give a function, if they ask what is the domain of the function, what I will check? For what values of x this function is defined? That only I will check. You observe the second problem, f of x equal to root x. What is domain of this function? What I said, how to calculate domain of a function? For what values of x the function is defined, that is called domain of the function. In real system, this is all about real system only. Whatever I am discussing today, all are about real system only. What is root over minus 4? What is the value of root over minus 4? The value of root over minus 4 is not defined. In real system, it is not defined. In complex system, it is 2a. That is another case. I am asking you in real system. Whatever is there in under root, that must be positive. Root 0 is what? Root 0 is 0. That means whatever the expression is there in under root, it must be greater than or equal to 0. So, what is the domain of this function? Yes, domain of this function is what? Domain of this function, root 4, 2, root 3, 1.732, root 2, 1.414. Like that for all real numbers, it is defined. But when this x is negative, then root over minus 4 in real system is what? Root over minus 4. It is not defined. It is not defined. I hope you are understanding. What is the domain of this function? For what values of x the function is defined, that is known as domain of the function. Here x is what? X can be taken as all positive real numbers including 0. So what is domain of this function? Domain of this function is all positive real numbers including 0. You observe here, what is the domain of this function? All real numbers except 0. Why 0 is removed here? If I take 0, f of 0 is not defined. Here minus 1 is there in this set. In this set minus 1 is there? No, minus 1 is not there. If you write minus 1 here, f of minus 1 is what? F of minus 1 is root over minus 1. What is root over minus 1? Root over minus 1 is not defined. I hope you are understanding. So, what is the domain of this function? Domain of this function is all positive real numbers including 0. Okay. You observe this one, f of x equal to x minus 1 divided by x minus 2. What they are asking in the question? Find the domain of this function. What is the domain of this function? Every time you keep this in your mind. For what values of x the function is defined, that is called domain of the function. For what values of x this function is defined? It is defined for all real numbers. So here it is very simple thing. If it is in the form of f of x by g of x, if denominator is 0, then this function is not defined. This is in the form of f of x divided by g of x. If this g of x is 0, then this function is not defined. When this function is defined? When x minus 2 is not equal to 0, then this function is defined. I hope you are understanding. When I take x equal to 2, what happening? Denominator is 0. That means this is not defined. You take f of 5. F of 5 is what? F of 5, I will calculate. F of 5. 5 minus 1. 4 divided by 5 minus 2, 3. 4 by 3 is defined now. So, what is the domain of this function? What is the domain of the function? For what values of x the function is defined, that is known as domain of the function. This function is defined for all real numbers. This function is defined for all real numbers except 2. What is f of 2? F of 2 is not defined because denominator is becoming 0. So what is domain of this function? Domain of this function is all real numbers except 2. I hope you are understanding. How to calculate domain of the function? For what values of x the function is defined, that is known as domain of the function. Now let's see one more example. F of x equal to log x base 3. What is domain of this function? For what values of x the function is defined, that is known as domain of the function. Here in logarithms chapter we know that this must be positive. It cannot be 0 also, but here it can be 0. But when it comes to logarithm, this must be positive. Log 2 value we can calculate by seeing logarithmic table. Logarithm of 0, by seeing table also you cannot say because log 0 is not defined. Logarithm of minus 1 is not defined. For what values of x the function is defined, that is known as domain of the function. What is domain here? For what are the x values? Logarithmic function is defined only for positive real numbers. So this domain is all positive real numbers. 0 is not included. Log 0 is not defined. So this x is what? Logarithmic function. Whenever log problems will come later in this series, you need to keep one point. Logarithm is defined only for positive real numbers. Okay, so what is the domain of this function? Domain of this function is all positive real numbers, right? You observe this one, f of x equal to x. What is the domain of this function? Yes, you only answer. Yes, answer please. What is the domain of this function? How to check? For what values of x the function is defined, that is known as domain of the function. It is defined for every real number. F of 0 is what? F of 0 is 0. F of 1 is what? F of 1 is 1. F of 1 by 2 is what? F of 1 by 2 is 1 by 2. This function is defined for all real numbers. So what is the domain of this function? Domain of this function is all real numbers. I hope you are understanding. Let's see one more small problem. F of x equal to 1 divided by x minus 1 into x minus 2. You observe this. This is of the form f of x divided by g of x, right? What is the domain of this function? For what values of x the function is defined, that is known as domain of the function. You observe here, when the denominator is 0, then this function is not defined. Here x minus 1 into x minus 2 cannot be equal to 0. When I put x equal to 1, this denominator is becoming 0 or not? Yes. So that means for the f of 1 is what? F of 1 is 1 divided by 0. That means this is not defined. What is f of 2? F of 2, 1 divided by 2 minus 1, 1 into 0. 1 into 0 is 0 only. So this is not defined. So what is domain of this function? Domain of this function is all real numbers except 1 and 2. You can take f of 100 you will get some value. F of 200 you take, f of 1 crore you take. But f of 1 is what? F of 1 is not defined. F of 2 is not defined. So domain of this function is what? All real numbers except 1 and 2. What we learn in this class? What we learn in this class? We learn about domain of a function. This is very easy only. Initially you may feel little difficult, but if you practice 10 to 15 problems, then you will get clear idea how to calculate domain of a function. Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is second class on domain of a function series. In last class, we learned what is domain of a function and we did 6 easy problems on how to calculate domain of a function. In this class, we will do another 6 problems. For what values of x the function is defined, that is known as domain of the function. You observe this question number 7, domain of square root of x square minus 25. How to calculate domain of this? In today's class, whatever the 6 problems I will do, in all 6 problems, this square root will be there. Here, what we learned in last class, whatever the expression is there in square root, this expression must be greater than or equal to 0. So here what I will write, x square minus 25 must be greater than or equal to 0. If x square minus 25 is less than 0, then this function is not defined. Okay, so what I need to find now? I need to find for what values of x this inequality holds good. That what I need to find. What I'll do first, I'll write this into linear factors. This 25 can be written as 5 square. See, x square minus 5 square is greater than or equal to 0. Now it is in the form of a square minus b square. A square minus b square formula is a plus b into a minus b. So x square minus 5 square can be written as x plus 5 into x minus 5. X plus 5 into x minus 5 greater than or equal to 0. Now what I need to find? For what values of x this inequality holds good? By using wavy curve method, we can easily say for what values of x this inequality holds good. What is that wavy curve method? As these are the linear factors, what I'll do, I'll equate this to 0. If I equate this to 0, you will get x equal to minus 5. Next, I'll equate this to 0, I'll get x equal to 5. Minus 5 plus 5. You mark them on the number line. Which one comes first? Minus 5 comes first. So minus 5, 5. After writing like this, in the rightmost corner, you write plus. As per wavy curve method, we will write like this. Blindly you write plus. Okay. Once in the rightmost corner, if you written plus, you write alternate symbols. Minus, after minus, alternate symbols plus like this. In this interval, this expression is positive. In this interval, this expression is negative. In this interval, this expression is positive. What I want greater than or equal to 0. Greater than or equal to 0 means positive or negative. Greater than or equal to 0 means we want positive sign. So where is the positive sign here? See, this is the zone. In this zone, this expression is positive. This is the zone. In this zone, this expression is positive. So what I'll write here, x belongs to minus infinity to minus 5. Here, you need to observe one thing. Here, greater than or equal to, equality symbol is there, na? That's why I'll write closed brackets. For infinity, always open bracket because infinity is not defined. Okay, minus infinity to minus 5. This interval I written union from here to here. What is this? This is 5 to infinity. Closed interval. Why I am writing closed interval? Because here equality is there. 5 to infinity. What I am trying to say, this expression is greater than or equal to 0 whenever x is in this interval. For example, you take one number in this interval. Suppose you take 6. 6 is there in this interval? Yes, 6 is there. 6 plus 5, positive or not? Okay. 6 minus 5, positive or not? Positive into positive, positive only, na? Right? You see here, you take any number here. What number I can take? Minus 6 I can take. Minus 6 plus 5. Minus 6 plus 5, negative. Minus 6 minus 5, negative. Negative into negative, positive only, na? So in that way, we can easily find in what interval this expression is positive. Suppose you take any number in this interval, this expression is clearly negative. If you want to check, just check like this. Suppose 0 is there in this interval. You put x is 0, 0 plus 5, positive. 0 minus 5, negative. Positive into negative, negative. So whatever you take, suppose I want to know in what interval this expression is negative, I will take this interval. I hope you understand, right? what is the domain of the function? This is the domain of the function. When I take x value in this interval, this expression is there, na, x square minus 25, that will be greater than or equal to 0, then this function is defined. So domain of this function is what? Minus infinity to minus 5 union 5 to infinity. I hope you understand this. You observe this question, 1 divided by square root of x square minus 25. I want to calculate domain of this function. To calculate domain of this function, you observe this is of the form f of x divided by g of x. When the given function in the form of f of x divided by g of x, denominator cannot be equal to 0. This part cannot be equal to 0. And you observe in this function square root is also there. When square root is there, whatever the expression is in square root, it must be greater than or equal to 0. So what I'll write here, I'll write like this, x square minus 25. Yes, this expression is in square root, I'll write like this, greater than or equal to 0. But equal to 0, x square minus 25 equal to 0. If I take x square minus 25 is 0, this denominator is becoming 0, then this function is not defined. So what I should consider here, I should consider x square minus 25 strictly greater than 0. I hope you are understanding. This function is defined only when x square minus 25 is greater than 0. Even though it is in square root, as it is in the denominator, we will take strictly greater than. Got the point? Now what I need to find? For what values of x this expression is greater than 0. For that I am going to use wavy curve method. For that I need linear factors. X square minus 25 can be written as x plus 5 into x minus 5. 25 can be written as 5 square, na? Right. Now as I got the linear factors here, by using wavy curve method, I can say for what values of x this inequality is positive. You take the number line. You equate this to 0. You will get x equal to minus 5. Minus 5. Okay. You equate this to 0. You will get x equal to 5. After that, in the rightmost corner, you write plus. Rightmost corner, you write plus. And then alternate symbols. Minus, plus. What I want here, I want for what values of x this expression is greater than 0. Greater than 0 means positive only, na? I want for what x values this expression is positive. So in this area, in this interval, this expression is positive. In this interval, this expression is positive. In this interval, this expression is negative. Greater than 0 means I want positive sign. So what I'll write? X belongs to minus infinity to minus 5. Here minus 5. For minus 5, closed interval or open interval. You see here strictly greater than is there, na? When strictly greater than is there, you take open interval. Union. I want positive sign, na? Open interval. Again open interval because strictly greater than. Open interval 5 to infinity. If I take any x value in this interval, this function is defined. Suppose if I take x value in this interval, this function is not defined. So what is domain of a function? In last class also, we clearly specified what is domain of a function. For what values of x the function is defined, that is known as domain of the function. For what values of x the function is defined, that is known as domain of the function. So what is domain of this function? Domain of this function is minus infinity comma minus 5 union 5 comma infinity. I hope you understand this. You observe this question number 9. I want to find domain of this function. First thing, in this question, square root is there. What you know, whatever the expression is there in under root, it must be greater than or equal to 0. So what you need to know here, 25 minus x square is greater than or equal to 0. Now, this function is defined only when this expression is greater than or equal to 0. What you need to find? For what values of x this inequality holds good? I can calculate this very easily with the help of wavy curve method. But to calculate with the help of wavy curve method, this expression must be in the form of x minus a into x minus b. I want this expression in the form of x minus a into x minus b. Then I can easily calculate the values of x with the help of wavy curve method. This complete inequality I will multiply with minus. This complete inequality you multiply with minus. This minus will become plus. X square minus 25 is less than or equal to 0. When I multiply this complete inequality with minus, we know that in an inequality, if we multiply with a negative real number, inequality sign changes. Here greater than or equal to changes to less than or equal to. Now you see it is x square minus 25. 25 can be written as 5 square. So this is what? This is x plus 5 into x minus 5. Less than or equal to 0. Now I need to find out for what values of x this inequality holds good. Can I use wavy curve method here? If it is in the form of x minus a into x minus b, then I can apply. I can apply to this. Now on the number line, you equate this to 0, you will get minus 5. You equate this expression to 0, you will get minus 5. You equate this expression to 0, you will get plus 5. Now in the rightmost corner, plus, alternate symbols, minus, plus. What is there here? Less than or equal to 0. Less than or equal to 0. That means less than 0 means I want negative sign. See here, in this interval, this expression is negative. So what I'll write here, x belongs to closed interval or open interval. Here equality is there, na? Equality is there means closed interval. Closed interval minus 5 comma 5. I hope you are understanding. So what is the domain of this function? Domain of this function is closed interval minus 5 comma 5. You take any x value in this interval, this expression is positive. That means this function is defined. If you take any number other than this interval, this function is not defined. For example, 6 is not in this interval. You take 6 here. 6 square is 36. 25 minus 36. What happened? In the under root, you are getting negative number. Then this function is not defined. So what is domain of the function? For what values of x the function is defined, that is known as domain of the function. So what is the domain of this function? Closed interval minus 5 comma 5. Okay. Question number 10. I want to find domain of this function. You can observe in this question, the square root is there. What you know, whatever the expression is there in square root, that must be greater than or equal to 0. So what I'll write here, x minus 2 divided by x plus 2. This expression must be greater than or equal to 0. And you observe this is of the form f of x by g of x. When the given function is in the form of f of x by g of x, then g of x cannot be equal to 0. This is in the form of f of x by g of x. Now this cannot be equal to 0. X plus 2 cannot be equal to 0. If x plus 2 is 0, this expression is not defined. I hope you are understanding. When this function is defined, whatever is there in under root, it must be greater than or equal to 0. Whatever is there in the denominator, it cannot be equal to 0. So you need to find the values of x which satisfies this condition. Here, what x value satisfies this condition? Here I can use wavy curve method. X minus a divided by x minus b form, so that I can use wavy curve method. As per the wavy curve method, you equate this to 0. X minus 2 equal to 0 means x equal to 2. You mark it on the number line as per the number line order. You equate this to 0. X plus 2 equal to 0, then x is minus 2. Then you write like this as per number line order. Okay. Now, in the rightmost corner, plus. Next, minus, alternate symbols, plus. Now I want to know for what x values this expression is greater than 0. Greater than 0 means positive sign you want. This x in this interval, this expression is positive. In this interval, this expression is positive. In this interval, this expression is negative. I want greater than 0, that means positive sign. So what I'll write, x belongs to, what is there here, minus infinity to minus 2. Here closed interval or open interval. Here greater than or equal to is there. Na? So you may feel that you will write closed interval. But if I write closed interval, minus 2 is included. You see here, x plus 2 not equal to 0 means x cannot be equal to minus 2. In this interval, minus 2 is included. So what I'll do here, I'll write open interval. If I write open interval, minus 2 is not included. Okay. Union 2 to infinity. 2 to infinity. So this is the interval. In this interval, these conditions holds good. So what is the domain of the function? Domain of this function is open interval minus infinity to minus 2, union 2 to infinity. I hope you understand this. You observe this question number 11. I want to find domain of this function. What thing you need to observe in this question? This is in this function square root is there. So whatever the expression is there in under root, it must be greater than or equal to 0. So what I'll write, x minus 1 into x plus 1 into x plus 2. This must be greater than or equal to 0. Now what I need to find, for what values of x this inequality holds good. For this I can use wavy curve method. In that method, first what I'll do, I'll take a number line. Equate this to 0. What you will get? You will get 1. Okay. Equate this expression to 0. What you will get? You will get x equal to minus 1. Equate this expression to 0. You will get x equal to minus 1. That minus 1 I'll write here. You equate this expression to 0. X plus 2 equal to 0 means x is minus 2. So I marked the numbers as per the number line. Now in the rightmost corner plus. Now alternate symbols minus, plus, minus. What I want? Greater than 0. Greater than 0 means positive sign. In this interval, this expression is positive. In this interval, this expression is positive. As I want positive sign, where is the positive sign? That is the domain of this function. In this interval, see here, greater than or equal to is there. Na? As equality is there, I will take closed interval. Closed interval, minus 2 comma minus 1. Okay, union 1 to infinity. I want positive sign na closed interval or open interval. Here equality is there na 1 to infinity. For infinity always open interval, open brackets, right? So what is the domain of this function? Closed interval minus 2 comma minus 1 union 1 to infinity. You observe this question number 12. We want to find domain of this function. You can observe two things here. One is it is in the form of f of x divided by g of x. Second one, in this function, square root is there. We know that whatever the expression in square root, it must be greater than or equal to 0. So, x square minus 6x plus 5 must be greater than or equal to 0. And one more thing, as it is in the form of f of x divided by g of x, this g of x cannot be equal to 0. This denominator cannot be equal to 0. If this denominator is 0, this function is not defined. But here I written greater than or equal to 0. That means I need to remove this equality here. So this function is defined only when this expression is greater than 0 because as it is in the denominator. Now what I'll do, I need to find for what values of x this inequality holds good. To apply wavy curve method, I want this in the form of x minus a, x minus b. So I'll split the middle term. This minus 6x I written as minus 5x minus x. Now, in these two, I'll take x common. Take x common, what you will get? X minus 5. In these two, you take minus common, then you will get x minus 5 greater than 0. So, x minus 5, if you take common, then you will get x minus 1 into x minus 5 is greater than 0. So, I just splitted the middle term, I got like this. Now, you see it is in the form of x minus a into x minus b. By using wavy curve method, I can easily say for what values of x this interval is greater than 0. Okay. Now equate this to 0, what x value you will get? You will get x equal to 1. Now equate this to 0, what x value you will get? You will get x equal to 5. As per the wavy curve method, rightmost corner, you keep plus first. Later alternate symbols, minus, plus. Now what I want, for what x values this expression is greater than 0. Greater than 0 means positive. In this interval this expression is positive. In this interval this expression is positive. So what I'll write, x belongs to, minus infinity to 1. Open interval or closed interval? Here strictly greater than is there, na? That's why it is open interval. Union 5 to infinity. For 5 also open interval because strictly greater than is there. So what is the domain of this function? Open interval minus infinity to 1 union open interval 5 to infinity. I hope you understand this class. Dear friends, it is all about practice. I am promising you again, I will do at least 50 to 60 problems on the domain of a function. And we always do from easy to difficult level. Okay, this is third class on domain of a function. In earlier classes, we learned what is domain of a function. Till now, we did 12 problems on domain of a function. In this class, we are going to do another 6 problems. Calculating domain of a function is nothing but finding the values of x for which the function is defined. In this class, whatever the 6 problems we will do, in all 6 problems, log will be there. Now, related to logarithm, what you need to know? Log a base b is defined only when this a and b both must be positive. A must be greater than 0 and b must be greater than 0. If a is 0, this function is not defined. If a is less than 0, this function is not defined. Log a base b is defined only when a and b are positive. And in the base, b cannot be. See, I said b is greater than 0. B is greater than 0 and b cannot be equal to 1. If b is equal to 1, then also this function is not defined. All these things we already learned in the definition of logarithmic function. To understand the problems in this class, these things you must know. This log a base b is defined only when a and b are positive real numbers and this base cannot be equal to 1. You need to keep these points in your mind to understand today's problems. You observe this question number 13. We want to find domain of logarithm of x plus 2 base x. When this function is defined, see here, this part must be greater than 0 and this part also must be greater than 0 and base cannot be equal to 1. That is what we learned just now. Okay. So here logarithm is defined only for positive real numbers. So what I'll write here, x plus 2 must be greater than 0 and this x also greater than 0 and this base value cannot be equal to 1. Now what I need to find, for what values of x all these things holds good. Okay, here x plus 2 greater than 0 means what is x? Take 2 to other side. X is greater than minus 2 and x is greater than 0 and x not equal to 1. To identify the x values which satisfies all three conditions, I'll use number line. You observe the numbers here, minus 2 is there, 0 is there, 1 is there. I'll mark them on the number line as per number line order. Now x greater than minus 2. I'll mark that x greater than minus 2. Here equality is not there. That means this is that one. See, x greater than minus 2 means all these values are greater than minus 2. Okay, now you see here x greater than 0. X greater than 0 means, see, 0 is not included. All these values are, you observe, all these values are greater than 0. Now what is the intersection part of these two? What are the common elements in this set as well as in this set? This part is common in both. Okay, if you take any number here, that value is greater than minus 2 and that value is greater than 0 also. And you observe here one more condition is there. What is that? X is not equal to 1. X is not equal to 1. You observe this is the common part. Now in that x equal to 1 is there. So I need to remove that x equal to 1. What is the domain of this function? The values of x which satisfies all three conditions. The values are here, see. So actually 0 to infinity, but I need to remove 1 now. So what I'll write? Open interval 0 comma 1 union open interval 1 to infinity. So what is domain of this function? Domain of this function is open interval 0 comma 1 union 1 to infinity. If I take any value in this interval, then this function is defined. That's why this is known as domain of this function. You observe this question number 14. We need to calculate domain of this function. Here, whatever is there, this must be greater than 0. If nothing is given means it comes under common logarithm. That means here base 10 will be there. Here, you do not worry about what is there here. Logarithm is defined for only positive real numbers. Now, what you need to know, whatever this part is there here, this part must be greater than 0. So, modulus of log x must be greater than 0. And you observe this one. In this, here x is there. Log x. That means this also must be greater than 0. What I am saying, you observe. Log of something. That means this is defined only for positive real numbers. That's why I written this expression is greater than 0. And again log is there, log of something. That means this also must be greater than 0. That's why I written here. Now I need to find the x values which satisfies both the condition. You observe here as modulus is there. You see modulus is there. Modulus always gives the positive expression. But modulus gives an expression of 0 also. Is it possible that this value will become 0? Is it possible that this value will become 0? Yes. When I take x is 1, what is log 1 value? Log 1 value 0 na? So here I cannot take x equal to 1. If I take x equal to 1, what happening? If I take x equal to 1, log 1 is 0. Modulus of 0 is 0. That means here this condition fails. So what are the x values satisfying this inequality? You take any x value other than 1, this condition holds good, and x greater than 0. So for these x values, both the inequalities holds good. Then how I'll write domain of this function? Here you observe x greater than 0, all positive real numbers, but x cannot be equal to 1. So how I can write? I can write like this. Open interval 0 to 1 union 1 to infinity. You can observe from 0 onwards all the positive real numbers are there except 1. 1 is not included. So for these values this function is defined. So what is the domain of this function? Open interval 0 comma 1 union 1 comma infinity. You observe this question number 15. I want to find domain of this function. What is this function? Logarithm of modulus of x square minus 9. What we know, logarithm is defined only for positive real numbers. Whatever the expression is there, it must be greater than 0. So what I'll write here, modulus of x square minus 9 must be greater than 0. Now I need to find the values of x which satisfies this condition. You observe, this is modulus. We know that modulus always gives positive real numbers. There is a chance of 0 also. Is it possible that this expression will become 0? Is it possible that this expression will become 0? Yes, it is possible. When I take x equal to plus 3, 9 minus 9, 0. Then at the time this condition fails. When I take x equal to minus 3, at that time also this will become 0. So when I take x value 3 minus 3, in that case this inequality fails. Other than minus 3 plus 3, you take any real number, this condition holds good. So what is domain of this function? Domain is all real numbers except 3 comma minus 3. You take any real value. Suppose you take 4, you will get positive expression only. You take 100, this is positive expression only. You take minus 2, this is positive expression only. You take any real value other than 3 and minus 3, this condition holds good. So what is the domain of this function? Domain of this function is all real numbers except 3 minus 3. You observe this question number 16. We want to find domain of this function. 1 divided by logarithm of x minus 2. Here log is there. When log is there, this expression must be positive. That means x minus 2 greater than 0. Then only this log of something is defined. Okay. Now as it is in the form of f of x divided by g of x, this denominator part cannot be equal to 0. Is it possible that denominator part will be 0? Yes. When this value is 1, at that time this denominator will become 0. X minus 2 cannot be equal to 1. If x minus 2 equal to 1, log 1 value is 0. That means this denominator is becoming 0. This function is not defined. Okay, so here x not equal to, you take minus 2 to this side, 3. So x cannot be equal to 3. If x equal to 3, 3 minus 2 is 1. Denominator is becoming 0. This function is not defined. Now we need to find the x values which satisfies both the conditions. See, x minus 2 greater than 0 means x is greater than 2. So I need the values which are greater than 2 and not equal to 3. So what is domain of this function? I can write like this. Domain x greater than 2. 2 to infinity. But in between 2 to infinity, 3 is there. I need to remove 3. So I'll write like this. Open interval 2 to 3 union 3 to infinity. So domain of this function is open interval 2 comma 3 union 3 comma infinity. You observe this question number 17. I need to find domain of this function. Logarithm of x square minus 1 base 3 plus x. You know that logarithm is defined for positive real numbers only. That means this expression must be greater than 0. X square minus 1 must be greater than 0. And whatever the base is there, that is also greater than 0. So 3 plus x greater than 0. And this base cannot be equal to 1. That is what we learned in the beginning of this class. This base cannot be equal to 1. 3 plus x cannot be equal to 1. I'll start simplifying all these things. You observe here, x square minus 1 can be written as x plus 1 into x minus 1. Okay, what x value satisfies this condition? For that, I am going to use wavy curve method that we learned in previous class also. Here x value is minus 1. Here you equate this to 0, you will get x value minus 1. You equate this to 0, you will get x value 1. Here rightmost corner plus and then alternate symbols minus plus. As we want greater than 0, that means positive sign. So when x value is in this interval, this expression is positive. When x value is in this interval, this expression is positive. Now come here. What is x here? X is greater than minus 3. You take plus 3 to other side. X is greater than minus 3. And here x cannot be equal to, you take 3 to other side, 1 minus 3. 1 minus 3 is minus 2. Now I'll mark all these conditions on the number line so that we can easily identify intersection of all these conditions. Okay. Now you observe here what numbers are there. I'll mark first minus 3. Okay. Minus 2. Minus 2 is there here. Minus 2 I written. Next minus 1, 1. Okay, you observe this one, minus infinity to minus 1. This part. This is the part. Minus infinity to minus 1. Okay, and 1 to infinity. 1 to infinity also I'll mark. 1 to infinity also I'll mark. Now, x greater than minus 3. This is over. These are the x values. These are the x values. Minus infinity to minus 1. Union 1 to infinity. These are the x values satisfies this inequality. X greater than minus 3. X greater than minus 3 means here. Here, greater than minus 3. All these values are greater than minus 3. Okay. And x not equal to minus 2. You cannot take this value. You cannot take this value. Open circle. Domain is the common area of all these intervals. You observe, this is the part common in both. So, open interval minus 3 to minus 2. Okay, minus 2 is not included because x cannot be equal to minus 2. And minus 2 comma minus 1. This is also covered, which is common in both. And this is also common. So, union 1 to infinity. So, if I take x value in this interval, then all three conditions are satisfied. If you want, you can check, right? So, domain of this function is what? Domain of this function is open interval minus 3 comma minus 2 union minus 2 comma minus 1 union 1 comma infinity. You observe this question number 18. We want to find domain of this function. What is this function? 1 divided by logarithm of mod x. In this logarithm is there, na? This expression must be greater than 0. I'll write here. Mod x must be greater than 0. And you observe given function in the form of f of x divided by g of x. That means this denominator cannot be equal to 0. Is it possible that denominator will become 0? Yes. When this value is 1, log 1 value is 0, na? So this modulus of x cannot be equal to 1. Now I need to find the values of x which satisfies both the conditions. Modulus of x greater than 0. See here, all real numbers satisfies this condition except 0. All real numbers satisfies this condition except 0. Suppose if I take x is minus 2. What is modulus of minus 2? Modulus of minus 2 is 2. 2 is greater than 0. Satisfying the modulus of 5. Modulus of 5 is 5. 5 is greater than 0. What x value satisfies this condition means all real numbers except 0. When I take x is 0, modulus of 0 is 0. 0 is not greater than 0. 0 equal to 0. What I am trying to say, what x value satisfies this condition? All real numbers satisfies this condition except 0. Okay. And modulus of x not equal to 1. When modulus of x value will become 1? When x is 1, modulus of 1 is 1. When x is minus 1, what is modulus of minus 1? Modulus of minus 1 is plus 1 only. We already know that. So, when x is minus 1, modulus of minus 1 is 1. So, when modulus of x will be 1, when x equal to 1, then modulus of x is 1. When x equal to minus 1, then also modulus of x is 1. So, x cannot be 1, x cannot be minus 1. I hope you are understanding. If x is 1, this is log 1. Log 1 means this denominator will becoming 0. This function is not defined. When x is minus 1, modulus of minus 1 is 1. So, log 1 is 0. Denominator is becoming 0. So, this function is not defined. That's why x value cannot be 0, x cannot be 1, x cannot be minus 1. So, what is domain of this function? Domain of this function is all real numbers. All real numbers satisfies this condition except 0, minus 1, plus 1. You take 1, this denominator is becoming 0. You take minus 1, this denominator is becoming 0. When you take x is 0, log 0 is not defined. Logarithm is defined only for positive real numbers now. So, domain of this function is all real numbers except 0, minus 1, 1. I hope you understand. Today, whatever the problems we did, all are based on logarithms. This is 4th class on domain of a function video series. Finding domain of a function is nothing but finding the values of x for which the function is defined. In first class, we learned basic problems. When given function is of the form f of x divided by g of x, then how to calculate its domain. In second class, in the given function, if square root is there, then how to calculate its domain. That is what we learned in second class. In third class, in the given problem, if logarithm is there, then how to calculate its domain. That is what we learned in third class. In fourth class, we are going to do the problems which contains logarithm as well as square root. These problems are going to be little tougher. And especially last problem in today's class is little difficult one. I want you to watch full video to understand that question. Till now we completed 18 problems in 3 classes. In this class we are going to do another 4 problems. You observe this question number 19. I want to calculate domain of this function. In this question you can observe 2 things. Logarithm is there as well as square root is there. Actually, if we consider this as f of x, if we consider this as g of x, if d1 is the domain of the first function and d2 is the domain of second function, then domain of f of x plus g of x is d1 intersection d2. That is what we learn in functions chapter. So to calculate domain of this function, what I'll do? First I'll calculate domain of this, that is nothing but d1. Next I'll calculate domain of this, that is nothing but d2. Later I'll do the intersection of d1 and d2 to calculate domain of this function. Okay, I'll calculate domain of this part first. You observe in this logarithm is there. In last class we learned this function is defined only when this part is greater than 0. Logarithm is defined for positive real numbers only, na? So what I'll write here, 1 minus x greater than 0. This function is defined only when 1 minus x is greater than 0. Here I'll multiply this entire inequality with minus to get x values. When I multiply this entire inequality with minus, here this minus will become plus. This will become x minus 1. For an inequality, if we multiply with a negative real number, we know that it changes its sign. This greater than changes to less than. I hope you understand. From this, what is x? X is less than 1. So, we calculated d1. What is d1 here? Minus infinity to 1. So domain of this part is minus infinity to 1. Now I'll calculate domain of this function. Here under root is there. Now whatever the expression is there in under root, that must be greater than or equal to 0. So here x square minus 1 must be greater than or equal to 0. Then only this part is defined. Okay, here I will write it into linear factors. X square minus 1 can be written as x plus 1 into x minus 1 greater than or equal to 0. Now I need to calculate for what x values this inequality holds good. What I'll do, you equate this to 0, you will get x equal to minus 1. I'll mark it on the number line. You equate this to 0, you will get x equal to 1. I'll mark it on the number line. In the rightmost corner, you keep plus and then alternate signs, minus, plus, like this. In this interval, this expression is positive, and in this interval also, this expression is positive. Now, what x values satisfies this inequality? X belongs to minus infinity to minus 1. Here closed interval or open interval? Here greater than or equal to is there, na? That's why closed interval. Union 1 to infinity. Closed interval, because here equality is there. In this interval, this expression is positive. Closed interval 1 to infinity. What is this? This is d2. Domain of this part I got. What you know, if domain of f of x is d1 and domain of g of x is d2, then domain of f of x plus g of x is d1 intersection d2. So what I need now? I need intersection of these two sets. To explain the things clearly to you, I'll mark these two sets on the number line. You can observe in this set as well as in this set, two numbers are there, 1, minus 1. I'll mark them on the number line as per number line order. Now, I'll mark this set on the number line. X is less than 1. This is strictly less than 1. That means 1 is not included. X is less than 1. 1 is not included, and that's why I'll write open circle. X is less than 1 means this is the part. This is the part in this interval all x values are less than 1. Now, I'll mark this set on the number line. Minus infinity to minus 1. See here, minus infinity to minus 1. This is minus infinity, here plus infinity will be there. Minus infinity to minus 1. Minus 1 is included or not? Yes, minus 1 is included. So here, closed circle. If I draw closed circle, it indicates that minus 1 is included. Minus infinity to minus 1 is included, and 1 to infinity. Here closed interval is there, na? Closed interval means 1 is included. Okay, closed interval 1 to infinity. You observe here, this is the first set. All x values less than 1. This is the second set. Now what I need? Intersection of these two sets. Where is the area common to this set as well as this set? This is the area which is common in both. So what is this area? This area will be the domain of this function. What is domain? Domain is minus infinity. For infinity, we always write open interval. Minus infinity to 1, minus 1. Minus infinity to minus 1. Here, minus 1 is there in this set and minus 1 is there in this set also. So, minus 1 is included. When it is included, I will write closed interval. So, what is the domain of this function? Open interval minus infinity comma closed interval minus 1. If I take any x value in this interval, when I substitute in this function, then this function is defined. That's why this is known as domain of this function. I hope you understand this problem. Now, you observe this question number 20. We need to calculate domain of this function. In this, square root is there as well as logarithm is also there. You can observe this given function is of the form f of x plus g of x. What I'll do, I'll calculate domain of f of x, that I'll take it as d1. Next, I'll calculate domain of g of x, that I'll take it as d2. What is domain of f of x plus g of x? Domain of f of x plus g of x is d1 intersection d2. So what I am going to do now, first I'll calculate domain of this part. Next, I'll calculate domain of this part. Later, I'll do intersection. Then I'll get domain of this full function. Okay. You observe here, to calculate a domain of this function, here square root is there. Na? Whatever the expression is there in under root, it must be greater than or equal to 0. So, x minus 2 must be greater than or equal to 0 because it is in under root. Na? From this, what is x? You take 2 to that side, x is greater than or equal to 2. So, this is d1, greater than or equal to 2 means 2 to infinity, 2 is included because here equality is there. Now, you observe this, I calculated d1. Now, I will calculate d2. You observe, in this logarithm is there. We know that logarithm is defined only for positive real numbers. So, this part 4 minus x must be greater than 0. 4 minus x must be greater than 0. And you can observe one more thing here. This is of the form f of x divided by g of x. Na? This is of the form f of x divided by g of x. This g of x cannot be equal to 0. Is it possible that this whole thing will become 0? Yes. When this value is 1, we know that log 1 value is 0. Na? So, when this value is 1, this denominator will become 0. So, 4 minus x cannot be equal to 1. If 4 minus x equal to 1, then this will become log 1, denominator will become 0, then this is not defined. So, to calculate domain of this part, x values must satisfy both the conditions. Now, I will multiply this complete inequality with minus just to get x values. When I multiply complete inequality with minus, this 4 minus x will become x minus 4. We know that in inequalities, if I multiply with a negative real number, it changes its sign. Greater than changes to less than. X minus 4 less than 0. And see here, x is what? You take minus x to that side and 1 to this side. Then what you will get? X cannot be equal to 3. If x equal to 3, this will become 1. Okay. So, what you will get here? X less than 4 and x not equal to 3. So, I calculated d2 also. What is d2? All x values which are less than 4. You can observe this is strictly less than. 4 is not included. X is less than 4. Minus infinity to 4. But x cannot be equal to 3. In minus infinity to 4, 3 is there now. So, what is domain of this function? Domain of this function is minus infinity to 3 open interval union 3 to 4 open interval. Okay. So, I calculated d1, I calculated d2. If d1 is the domain of f of x, d2 is the domain of g of x, then domain of f of x plus g of x is d1 intersection d2. So, I need intersection of this set as well as this set. To explain the things clearly, I will mark them on the number line. What I will do first, I will take intersection of this part and then I will consider x not equal to 3. Here two numbers are there. One is 2, another one is 4. Okay, 2, another one is 4. First, I will mark this set. X greater than or equal to 2. X greater than or equal to 2 means 2 is included. So, this is the area. This is D1. All values are greater than or equal to 2. Now, x less than 4. This is strictly less than 4. X less than 4. Open circle. All these values are less than 4. 4 is not included. Okay. Now what is the intersection of these two things? What is the intersection of these two things? You observe. Intersection of these two things is this part. This is first set. This is second set. Intersection of these two things is this part. What is that? I'll write here. X belongs to 2 is there in both the sets. Closed interval 2, comma 4 is not in this set, but 4 is in this set. 4 is in this set. So 4 is not in this set. 4 doesn't comes in the intersection. This is intersection of these two things. Here you observe the third condition, x not equal to 3. In this interval, 3 is there. Yes, 3 is there. But x not equal to 3. So what I can write? Simply, I can write like this. In this interval, I'll remove the number 3. Or else, you can write like this also. Domain equal to closed interval 2, comma open interval 3. Open interval 3 means 3 is not included. Union open interval 3, comma 4. So this is D1 intersection D2. If I take any x value in this interval, this entire function is defined. That's why this is known as domain of this function. I hope you understand this. You observe this question number 21. I need to calculate domain of this function. You observe log of mod x plus 1 divided by square root of mod x plus 1 divided by log of mod x. I need to calculate domain of this function. What I'll do first, I'll calculate domain of this part. I'll take it as D1. And then I'll calculate domain of this part. I'll take it as D2. Next, I'll calculate domain of this part. I'll take it as D3. Finally, to calculate domain of this full function, I'll calculate D1 intersection D2 intersection D3. First, we will calculate D1. D1 means domain of this part. You observe in this log is there. Na? We know that logarithm is defined for positive real numbers only. So whatever this part is there, that must be greater than 0. Greater than 0. Mod x greater than 0. What x values satisfies this condition? You take any real x value, then mod x is either positive or 0. Modulus of minus 2 is 2. Modulus of 2 is 2. Modulus of minus 100 is 100. Modulus of 100 is 100. Modulus of 0 is 0. Modulus function is either positive or 0. What I am trying to say here, this inequality holds good for all real numbers except 0. Here, x cannot be equal to 0. If x equal to 0, modulus of 0 is 0. 0 is greater than 0? No. Other than 0, you take any real number, this inequality holds good. So what is D1? D1 is all real numbers except 0. I hope you understand this. You observe this one. This is of the form f of x divided by g of x. So this g of x cannot be equal to 0. And one more thing, this is in under root. Whatever the expression is there in under root, that must be greater than or equal to 0. Modulus of x must be greater than or equal to 0. But here, as this is in the denominator, denominator cannot be equal to 0. If mod x equal to 0, root 0 is 0, then this denominator is becoming 0, then this part is not defined. So here I need to consider strictly greater than. I hope you understand this. Mod x is greater than 0. You observe this both are same now. So what x value satisfies this condition? All real numbers satisfies this condition except 0. So what is D2? D2 is all real numbers except 0. I hope you are understanding. Now I'll calculate this part. This is also of the form f of x divided by g of x. In this, log is there. We know that logarithm is defined only for positive real numbers. So whatever this part is there, that must be greater than 0. Mod x is greater than 0. And you observe it is of the form f of x divided by g of x. Na? This denominator cannot be equal to 0. Is it possible that denominator is 0? Yes. Here when this mod x value is 1, when mod x is 1, log 1 value is 0. Log 1 value is 0 means this denominator is becoming 0, then this function is not defined. So first thing, here log is there, that's why this expression must be greater than 0, and mod x value cannot be equal to 1. Cannot be equal to 1. If mod x equal to 1, this is log 1. Log 1 is 0. Denominator is 0 means this part is not defined. Okay, now I need to find x values which satisfies both the conditions. Mod x greater than 0. Same like this here. Mod x greater than 0 means x not equal to 0. And mod x cannot be equal to 1. For what x values, mod x will be 1. Modulus of minus 1 is what? Modulus of minus 1 is 1. That means here x cannot be equal to minus 1. If x is minus 1, modulus of minus 1 is 1. As mod x not equal to 1, x cannot be equal to minus 1 and x cannot be equal to 1 also. Okay. So this is D3. What is D3? All real numbers except 0, minus 1, 1. I hope you are understanding. So what is the intersection of all these three sets? Now what I need? I need intersection of all these three sets. In all these three things you observe x not equal to 0, x not equal to 0, x not equal to 0, x not equal to 1, x not equal to minus 1. You can take any real number other than these values. So what is the intersection of these three things? Intersection of these three things is the domain. Domain is all real numbers, but x cannot be equal to 0 and x cannot be equal to minus 1. X cannot be equal to 1. If you take any x value in this interval, then this function is defined. That's why this is known as domain of this function. Finding domain of a function is nothing but finding the values of x for which the function is defined. Now last problem, it is little difficult one. I request you to pause this video and try this problem your own, then you will come to know the difficulty of this problem. You observe in this square root is there, logarithm is also there. How to find domain of this function? We know that whatever the expression is there in under root, that must be greater than or equal to 0. This is the expression which is in under root. This expression must be greater than or equal to 0. And you see here log is there. Log is defined only for positive real numbers. Log of x minus 1 is defined only when this part is greater than 0. So x minus 1 is greater than 0. Now you observe in under root, it is in the form of f of x divided by g of x. This denominator cannot be equal to 0. If this denominator is 0, then this is not defined. So x square minus 2x minus 8 cannot be equal to 0. So we need to find the x values which satisfies all three conditions. Finding the values of x which satisfies this inequality is little complicated. Some other methods also there, but I want you to understand this clearly. So I am going to do this in little lengthy method, but you will understand this clearly. You observe this expression here, this middle term, I'll split the middle term. Minus 2x, you write it as minus 4x plus 2x. Then you will get this x plus 2 into x minus 4. You see, you multiply x square, minus 4x plus 2x is minus 2x is minus 8. I just split it the middle term, I written in factor form, is greater than or equal to 0. I will come to this part later. First let me find the values of x which satisfies this inequality. This part is little complicated. Now when this total expression is greater than or equal to 0, when this is positive, when this is also positive, then this total expression is positive. Okay. Another case is what? When this expression is negative, when this expression is also negative, then this whole expression is positive. I will calculate both the cases. You observe here, I am calculating case 1. What is case 1? This part is greater than 0, this part also greater than 0. So what I will write here, logarithm of x minus 1 is greater than or equal to 0, because equality is there, this is okay. And whatever this x plus 2, x minus 4, this is greater than 0. Denominator cannot be equal to 0. If this expression is positive, this expression is positive, then this total inequality is positive only. That is the case 1. Okay. Now, one more thing you need to observe here. This log is there, log expression is there. This expression is defined only when this is positive. So, you need to consider this also. What is that? X minus 1. X minus 1 is greater than 0. So here nothing is there means it is common logarithm, base 10 will be there. So what is x minus 1? X minus 1 is greater than or equal to 10 power 0. 10 power 0 is 1. From this what you will get? You will get x greater than or equal to 2. And you observe by using wavy curve method, we can say easily for what x values this inequality holds good. You equate this to 0, you will get x is minus 2. You equate this to 0, you will get 4. Now rightmost corner plus, minus, plus. As I need greater than 0, I need positive sign here. What x value satisfies this? X belongs to minus infinity to minus 2 open interval union 4 to infinity. And this part, x minus 1 greater than 0 means x greater than 1. Now I need intersection of all these three. This. First I will calculate intersection of these two. I am not marking on the number line. You please try to understand this. X greater than or equal to 2. X greater than or equal to means all x values are 2 or more than 2. You observe here, if I do intersection of these two, you observe here, this part is not in this set. You observe this part, negative numbers are not in this set, and 4 to infinity, here 2 to infinity, closed interval 2 to infinity. If I do the intersection of these two, what I'll get? Think, I'll get 4 to infinity. Intersection of these two sets is open interval 4 comma infinity. And you observe this one, x greater than 1. X greater than 1 means 1 to infinity. 4 comma infinity, 1 comma infinity. Intersection is what? Is 4 comma infinity. I hope you understand this. So, what are the x values satisfying all these three conditions? 4 to infinity. What you got? Case 1. Case 1, you got that x belongs to 4 comma infinity. So, if I take any x value in this interval, then this numerator part is also positive, denominator part also positive, positive divided by positive is positive. Now, second case, what is the case 2? If this part is less than 0, this part also less than 0, negative divided by negative is also positive. Na? So, I am going to calculate for what x values, this part is negative, this part also negative. See here, logarithm of x minus 1 less than 0, and here log is there. Na? So, this part is defined only when x minus 1 is greater than 0. So, I will write x minus 1 greater than 0. And what case I am considering? This is less than 0, this is less than 0. No? So, this is less than 0. X plus 2 into x minus 4 less than 0. Now, I need to calculate the x values which satisfies all three conditions. It is little difficult only. Have patience to understand this clearly. Here, base 10 will be there. What you will get? X minus 1 is less than 10 power 0. 10 power 0 is 1. So, x is less than 2. 1 plus 1 is 2. X is less than 2. X minus 1 greater than 0 means x is greater than 1. And for what values this expression is negative? You equate this to 0, you will get minus 2. You equate this to 0, you will get plus 4, plus, minus, plus. Less than 0 means negative sign. So, I need this. X belongs to open interval minus 2 comma 4. Now, I will take intersection of all these three. What is the intersection of these two? Intersection of these two is x belongs to open interval 1 to 2 you will get. Intersection of these two is open interval 1 to 2. I want you to know this clearly. If you are confused, then mark them on the number line and you can check. I'll do intersection with this interval. What is this interval? Open interval minus 2 comma 4. What is the common area in these two? Open interval 1 comma 2 we got here. Na? That open interval 1 comma 2 is there in this. Open interval 1 comma 2 is there in this. Yes. What is intersection of these two things? Intersection of these two things is open interval 1 comma 2. So, when I take x value in between 1 and 2, this expression is positive. And one more thing is, when I take x value in this interval, this is negative, this is also negative. If you want, you can check. So, what I got in second case, I got that x belongs to open interval 1 comma 2. In this part, in this interval, this expression is greater than or equal to 0. In this interval also, this expression is greater than or equal to 0. So, for what values this expression is greater than or equal to 0 means union of these two things. X belongs to 4 comma infinity union open interval 1 comma 2. In this interval, this expression is greater than or equal to 0. Now, till now, whatever I did, that is x value satisfying this inequality. I didn't consider this and this. Now you see here, x minus 1 greater than 0 means x greater than 1. If I split the middle term, what I'll get? This is x plus 2 into x minus 4 not equal to 0. So, x greater than 1 and x not equal to minus 2, x not equal to 4. Right. Now what I need? I need intersection of this. To explain intersection of all these things, I'll mark them on the number line. Here, what numbers are there? 1, 2, 4. 1, 2, 4. At the end, whatever I'll get in that interval, if I'll remove these numbers minus 2, 4. Okay. Now, 1 to 2, 4 to infinity. 1 to 2, open interval. 1 to 2 and 4 to infinity. This is the first set. 1 to 2, 4 to infinity. Second one, greater than 1. Greater than 1 means this part. If I take intersection of these two, what I'll get? I'll get this again. I hope you are understanding. Intersection of these two sets is what? Intersection of these two sets is this part and this part. That means I'll get this only. Okay. Now intersection of these two things is open interval 1 comma 2 union open interval 4 comma infinity. Now in this interval, these numbers are there or not, you check. You see all these are positive numbers only. X never be equal to -2. So no problem. In this interval 4 is there. Here this is open interval 4 na? That means 4 is not included. So when I do intersection of these three sets, I'll get this. So x belongs to open interval 1 comma 2 union 4 comma infinity. So this is domain of this function. This problem seems to be very simple, but so many complications are there in this. But if you do this type of problems, then only you will get good grip on the concept. Till now we did 22 problems on domain of a function. In this class we will do another 4 problems. You observe this question number 23. We need to find domain of this function. If D1 is the domain of f of x and D2 is domain of g of x, then domain of f of x plus g of x is D1 intersection D2. So to calculate domain of this function, first I'll calculate domain of this part and then I'll calculate domain of this part. Later I'll do their intersection to calculate domain of this entire function. Okay, first I want to calculate domain of this function. And first point, what is the domain of greatest integer function? Domain of greatest integer function is all real numbers. But this is of the form f of x divided by g of x na, this denominator cannot be equal to 0. Here, when this denominator will become 0, you know this one, step 0.1 is what? Step 0.1. Step 0.1 is in between the integers 0 and 1. Left hand side 0 is there na, so you will get 0. Step 0.3. What is step 0.3? Is 0. Step 0.786. What is step 0.786? This is in between the integers 0 and 1 na, you will get 0. This is what we learned in greatest integer function definition. I did a video on greatest integer function. If you want, you can check that. So whenever x value is in between 0 and 1, whenever x value is in between 0 and 1, then step x will become 0. What is step 0? Step 0 is 0. Whenever integer is there, same number will come. Step 1. Step 1 is what? Step 1 is 1. So when this denominator will become 0? When x is in this interval, closed interval 0 to open interval 1. You take any number in this interval, then step x is 0. Here, if this value is 0, then this function is not defined. So I need to remove this interval in its domain. So what is domain of this part? I'll write like this, D1. D1 means domain of this part I am calculating. Is open interval minus infinity to 0. Here you see 0 is not included. Open interval means 0 is not included. Union 1 to infinity. Here closed interval 1, because I can take x is 1. Step 1 is 1 to infinity. For infinity always open bracket. So domain of this function is what? Minus infinity to 0 union closed interval 1 to infinity. If I take any value in this interval, this denominator part is becoming 0, then domain of this part is not defined. I hope you understand. So from all real numbers, I just removed this interval to calculate domain of this part. Now I calculated domain of this part, I got D1. Now I will calculate domain of this part. You observe this is in under root na. From earlier classes we learned whatever the expression is there in under root, that must be greater than or equal to 0. So here 2x minus x square must be greater than or equal to 0. What I will do, this complete inequality I will multiply with minus to get x values easily. When you multiply an inequality with negative real number, inequality changes its sign. This greater than or equal to changes to less than or equal to. Now multiply this complete inequality with minus, then this is plus x square minus 2x. This greater than or equal to changes to less than or equal to 0. Now in these two, I can take x common. Take x common, what you will get if you take x common, x into x minus 2 less than or equal to 0. Now this x can be written as x minus 0 into x minus 2 less than or equal to 0. Now I need to find for what x values this inequality holds good. To calculate that, I'll use wavy curve method. On the number line, I'll mark these things. When I equate this to 0, I'll get x equal to 0. When I equate this to 0, I'll get x equal to 2. In the rightmost corner, plus, and then alternate symbols. What is d2? Here, less than or equal to is there, na? Less than 0 means negative sign. Equality is there, that's why closed bracket. 0 to 2. Closed interval 0 to 2. So, domain of this part is what? Closed interval 0 to 2. So, what I calculated domain of this. Domain of this is this one. Now, I calculated domain of this. That is this part. Now, what is the domain of this full function? I need intersection of these two intervals. To understand intersection of these two intervals, I'll mark them on the number line so that you can easily understand it. You observe 0, 1, 2. 3 numbers are there. I'll mark them 0, 1, 2 as per number line order. Now, I'll mark this set. Minus infinity to 0. Here minus infinity will be there. Here plus infinity will be there. No need to write that. Minus infinity to 0. That means this part. 0 is included? No, not included. So open circle. Minus infinity to 0. Union 1 to infinity. Here 1 is closed interval. Closed interval means 1 is included. So this is closed circle 1 to infinity. What is this? This is first set. Now I'll mark second set. Closed interval 0 to 2. 0 is included, 2 is included. Closed interval 0 to 2. This is closed interval 0 to 2. This is second set. See, this is the first set, this is the second set. Where is the common part in both the sets? You can observe, this is the part which is common in both. This is the part which is common in both. This is second set. This is first set. This is the part common in both. So, what is D1 intersection D2? D1 intersection D2 is closed interval. 1 is there in both the sets. Closed interval 1 comma 2. I hope you are understanding. So, if I take any x value in this interval, this function is defined. That's why this is known as domain of this function. What is domain of a function? You always keep this point in your mind. For what values of x the function is defined, that is known as domain of the function. You observe this question number 24. We need to find domain of this function. Logarithm of 1 minus x divided by 1 plus x base e. Here in this logarithm is there. We know that logarithm is defined for positive real numbers only. So whatever the expression is there here, that must be greater than 0. So what you need to write here, 1 minus x divided by 1 plus x must be greater than 0. Now I need to find for what values of x this inequality holds good. For that I'll use wavy curve method. To use wavy curve method, all the things I want in the form of x minus a, x minus b like that. But this is not in the form of x minus a. This is in the form of 1 minus x. To get this expression in the form of x minus a divided by x minus b, I'll multiply this complete inequality with negative number. We know that for an inequality, if we multiply with a negative real number, the sign changes, greater than changes to less than. Multiply this complete inequality with minus, this 1 minus x will become x minus 1 divided by 1 plus x, x plus 1 both are same only, less than 0. As I multiplied this inequality with negative real number, inequality changes. Now by using wavy curve method, I can easily say for what x values this holds good. Now you equate this to 0, you will get x equal to 1. You equate this to 0, you will get x equal to minus 1. You mark them as per number line order only. Okay, now in the rightmost corner, always keep plus. Later alternate symbols, minus, plus like that. Now less than 0. Less than 0 means negative sign. In this interval, this expression is negative. Here, this is strictly less than, so you need to write open interval. So, x belongs to open interval minus 1 comma 1. So, for these x values, this function is defined. That's why this is domain of this function. I hope you understand this. You observe this question number 25. We need to find domain of this function. You can observe here 3 logs are there. So, how to calculate domain of this function? You observe here, whatever the expression is there, this must be greater than 0 because logarithm is defined for positive real numbers only. So, what I'll write? This expression must be greater than 0. That's what I written. This must be greater than 0. And you can observe again here, log of something is there. Log of something, log of something. This part is defined only when this is positive. So, what I'll write here? And log x base 4 must be greater than 0. And you observe this log of x is there. This is defined only when this part is greater than 0. So here what is this? X greater than 0. So we need to find the x values which satisfies all three conditions. Here how to simplify this? From the definition of logarithm, what I can do, I can take this to here. This will become 3 power 0. If a power x equal to b, x equal to log b base a. We learned this in the definition of logarithmic function. If you want, you can check that video. What I'll do here, this can be written as log x base 4 greater than 3 power 0. 3 power 0. 3 power 0 is 1. Here, one important point. When this base value is less than 1, when this base value is less than 1, in between 0 and 1, when I take this to this side, at that time inequality changes. I'll do one problem like that in next class. Here, when I take 3 to this side, 3 power 0 is 1. Here this value is greater than 1, so inequality doesn't changes. Now further if I simplify this, here x can be written as, from the definition of logarithm, this number is greater than 1, you can take this to this side, 4 power 1. 4 power 1 is 4. So x is greater than 4 I got. Okay, now you come to this one. Here what I can write, and as per the logarithm definition, I can take 4 to this side. X is greater than 4 power 0. 4 power 0 is what? 4 power 0 is 1, and x is greater than 0. Now I need to find the x values which satisfies all three conditions. Intersection of all three, you see here, greater than 4. In this greater than 4 is there, right? In this also greater than 4 is there. What is the intersection of all these things? Simply think, it is very easy to say. What is intersection of all these things? Intersection of all these things is x is greater than 4. This is there in this set, in this set, in that set also. So what is the domain of this function? Domain of this function is x is greater than 4. You observe this question number 26. We need to find domain of this function. In this, you can observe log is there. So whatever the expression is there here, this must be greater than 0. So 2x cube minus x square minus 4x plus 2. This expression must be greater than 0. I want to write this into linear factors. If I write this into linear factors, I can easily say by using wavy curve method, for what x values this inequality holds good. To write this cubic equation into linear factor, I will use Horner's method. In Horner's method, first we will write like this. Here x cube term, x square term, x term, constant terms are there. X cube coefficient 2, x square coefficient minus 1, x coefficient minus 4, and constant 2. I'll write like this and I'll keep 0. Now I need to check by taking x values here. Here I checked that x equal to 1 by 2 if I take, this is satisfying. I'll take x equal to 1 by 2. Here 2 plus 0 is 2. 1 by 2 into 2 is 1. Minus 1 plus 1 is 0. 1 by 2 into 0 is 0. Minus 4 plus 0 is minus 4. Multiply these two. 1 by 2 into minus 4 is minus 2. Minus 2. You got 0 here. Now you can observe here 0 is there. Na? So the things will be simple. Here you take 1 by 2 to this side. What you will get? See, this expression can be written as x minus 1 by 2. Listen, this expression can be written as x minus 1 by 2 into, you come from here, constant x term, x square term. X term coefficient is 0. That means there is no x term in this. Constant x term, x square term. So what I will get here, this can be written as 2 into x square plus 0 into x. No need to write that. Minus 4. I hope you are understanding. By using Horner's method, this cubic equation can be written like this. If you want, you multiply these two things, then again you will get the same expression only. Okay, x minus 1 by 2 into, here I can take 2 common. In this I will take 2 common. Then what I will get? I will get x square minus 2. See, 2 into x square minus 2 is 2x square minus 4 only. Greater than 0. Now for this complete inequality, I'll divide with a positive real number 2. Then this will get cancelled. Now what I'll get? X minus 1 by 2 into, this 2 can be written as root 2 whole square. Then it is of the form a square minus b square. What is a square minus b square formula? A plus b into a minus b. Na? So this can be written as x plus root 2 into x minus root 2 greater than 0. Now you observe, I got everything in the form of x minus a, x minus b, x minus c. If it is like this, by using wavy curve method, I can easily find for what x values this inequality holds good. Now to identify that, I'll take the number line. this equate this to 0. First minus root 2. You equate this to 0, you will get x equal to root 2. That is 1.414. Now equate this to 0, you will get x equal to 1 by 2. 1 by 2 is 0.5. Something you will get like this. You need to mark this thing as per the number line order. Now in the rightmost corner, you keep plus and then alternate symbols. Now greater than 0. Greater than 0 means I want positive sign. I want positive sign. What is the positive sign? X belongs to. Here strictly greater than is there. So you need to write open interval. X belongs to open interval minus root 2 comma 1 by 2 union. I want positive sign root 2 to infinity. This function is defined only when this expression is greater than 0. For what x values this expression is greater than 0? When x is in this interval, then this expression is greater than 0. So whenever I take x value in this interval, this function is defined. That's why this is known as domain of this function. I hope you understand this class. To understand today's problems, it is important you must know what is fractional part function. This is graph of fractional part function. Fractional part function is denoted like this. F of x equal to like this. Flower bracket of x. This is fractional part of x. This is also written as x minus step x. Fractional part of x is nothing but x minus step x. Here you observe what is domain and range of fractional part function. That is what I want to discuss. What is domain? Is this function is defined for all real numbers? You see, it is defined for all real numbers. You take 0.5, respect to y value is there. You take 2.5, respect to value is there. You take minus 1.5, respect to value will be there. So domain of this function is all real numbers. You take any real number, respective value we can calculate. Okay, so domain of this function is all real numbers. What is the range of this function? Whatever x value you take, its answer is in between 0 and 1. Try to understand this please clearly. What is the range of this function? 0 is possible? Yes, you will get 0. When you will get 0, that also I will discuss. What is range of this function? Range of this function is closed interval 0 to open interval 1. You take any real value and substitute in this, you always get a number in between 0 and 1. If you want to check, you can check. For example, if you want to calculate fractional part of minus 1.5. In this, wherever x is there you write minus 1.5. Minus 1.5 minus step. In place of x, you write minus 1.5. Let's see what I will get. Minus 1.5 minus step minus 1.5. Here, minus 1.5 lies in between minus 2 and minus 1. Left hand side, what integer is that? That answer we will write. So what you will get here? This is minus 2. So minus 2. Here minus of minus plus. 2 minus 1.5. 2 minus 1.5 is 0.5. You try to understand what I am saying. Whatever real value you take, this fractional part function always gives a number in between 0 and 1. The important thing what I am trying to say, when this fractional part function gives 0, whenever you take x is an integer, its fractional part value is 0. You take any integer, suppose 2 is integer or not, I will calculate fractional part of 2. Right here 2 minus step 2. Okay, what you will get? 2 minus step 2 is 2 only. Right? 2 minus 2 is 0. What I am trying to say, fractional part function gives 0 whenever x is an integer. Okay. We learned that domain of fractional part function is all real numbers and fractional part function always gives the number in between 0 and 1. 0 is included, 1 is not included. You observe this question number 27. We need to find domain of this function. What is this function? Logarithm of x minus step x. Here, just now we learned that fractional part of x is nothing but x minus step x. So this x minus step x I can write like this, logarithm of fractional part of x. We know that logarithm is defined for positive real numbers only. Whatever the fractional part of x is there here, that must be greater than 0. Fractional part of x greater than 0. We know that fractional part of x value always lies in between 0 and 1. There is a chance that fractional part of x will be 0. But here fractional part of x we want greater than 0. whatever you take number in this interval, all are greater than 0 except 0. Now you need to identify the x values for which fractional part of x is 0. Just now we discussed now, whenever you take x is an integer, fractional part of x is 0. So what are the x values for which fractional part of x is greater than 0? That is all real numbers except integer. Please try to understand. In case if you take x is an integer, fractional part of x will become 0. As I need fractional part of x is greater than 0, I cannot choose integer. Other than integer, you take any real number, this fractional part of x gives a number in between 0 and 1. So what is domain of this function? Domain of this function is all real numbers except integers. So for these values, this function is defined. That's why this is domain of this function. This is interesting question and little difficult also to try. Alright, let's see the solution. You observe in this square root is there, na? Whenever square root is there, this expression in the square root must be greater than or equal to 0. So what I'll write here, logarithm of step x base fractional part of x must be greater than or equal to 0. Logarithm is defined for positive real numbers only, na? Step x base fractional part of x. We know that logarithm is defined for positive real numbers only. That's why this step x must be greater than 0 and fractional part of x also must be greater than 0 and this base value cannot be equal to 1. Now we need to find x values which satisfies all three conditions. Now first this one. You observe this. What is fractional part of x? We know that fractional part of x value is always in this interval. Whatever number you take, that number is in between 0 and 1. So you take this to this side, then what you will get? Step x. This value is in between 0 and 1. Na? In last class also I discussed it. When base value is in between 0 and 1, when I take this to this side, this inequality changes. This is what? This is some number in between 0 and 1. When I take this to this side, as per the definition of logarithm, this greater than or equal to changes to less than or equal to, because this is the number which is less than 1 in between 0 and 1. And what you will get? There is some number which is in between 0 and 1 whole power 0. Suppose 0.5 whole power 0 is what? Is 1. So you will get 1 here. I hope you understand this. As per the definition of logarithm, fractional part of x whole power 0 is 1 because fractional part of x is a value which lies in between 0 and 1. Base cannot be 0. We won't consider base 0. If base is 0, this is not defined. That value, that condition we will get here. Do not worry. Now, step x is less than or equal to 1. For what x values, step x is less than or equal to 1? You observe here, whenever I take an interval in between minus infinity to 2. You take any number in this interval, substitute here, its value is less than 1. For example, you take 1.9. Step 1.9 is 1. Right? Step minus 1.5, minus 2. Minus 2 is less than 1. You take any value in this interval, you substitute in this, it satisfies. Okay. So, these are the x values which satisfies this inequality. Come to this one. Step x is greater than 0. Step x is greater than 0. Equal to 0 is not given. Step x is greater than 0. What are the x values for which step x is greater than 0? Closed interval 1 to infinity. You take step 1. Step 1 is 1. That's why 1 is included. 1 is greater than 0. Na? Suppose if you take 0.9. Step 0.9 is 0. 0 is not greater than 0. So, all these values satisfies this inequality. Now, you observe this one. Fractional part of x greater than 0. Here, what x values satisfies this condition? Domain of fractional part of x is what? All real numbers. But whenever I take x is an integer, fractional part of x will gives you 0. So, what are the x values which satisfies this condition? All real numbers except integers. X is any real number other than integer satisfies this condition. If you take x is an integer, fractional part of x will become 0. I hope you are understanding. You take x is any real number other than integer, its answer is always greater than 0 and less than 1 also. What I need? I need x values which satisfies all three conditions. First, I'll do intersection of these two. Later, I'll intersect with this third interval. Intersection of these two. You observe what is intersection of these two. To understand you the things clearly, I'll mark these sets on the number line. Minus infinity to 2. you mark this on the number line minus infinity to 2, you will get like this. This is minus infinity to 2. Now 1 to infinity, you mark it on the number line. 1 is included here. That's why this is closed circle. 1 to infinity like this. What is the common part of these two sets? This is first set, this is second set. Common part is this. X belongs to 1 is there in both the sets. So X belongs to closed interval 1, open interval 2. So intersection of these two is closed interval 1, open interval 2. Now intersection of this set and this set. What is this set? All real numbers except integers. You observe in this any integer is there? Yes, 1 is integer. 1 is integer. When I do intersection of this set and this set, when I do intersection of this set and this set, what I'll get? I need to remove the integers, that's it. So intersection of these two sets is X belongs to open interval 1 comma 2. So if we take any x value in this interval, this function is defined. So what is domain of this function? Domain of this function is open interval 1 comma 2. You observe this question number 29. We need to find domain of x power 1 divided by log x. You observe this. Here log is there. Na? Log x defined only when this part is positive. So x must be greater than 0. And you see here, this is of the form f of x by g of x. Here f of x by g of x is there. Na? This g of x cannot be equal to 0. That means log x cannot be equal to 0. If log x is 0, then denominator will become 0. Then this function is not defined. Now we need to find x values which satisfies this condition. Okay, x greater than 0. This is clear. Now log x not equal to 0. When this log x is 0, when this x value is 1, log 1 is 0. That means x cannot be equal to 1. X value cannot be equal to 1. That's it. So what is domain of this function? All x values which are greater than 0, but x cannot be equal to 1. This is very simple problem, but by seeing this problem we will confuse initially, right? So what are the x values satisfying both the conditions? All positive real numbers except 1. So I'll write like this: open interval 0 to 1, union 1 to infinity. As I written open interval, 1 is not included. All positive real numbers except 1, or else you can write like this also: all positive real numbers except 1. You can write like this also. I hope you understand this. You observe this question number 30. By seeing question itself, you may worry because so many things are there in this question. You observe square root is there, modulus is there, step function. This is step function. Step mod x minus 1. Two modulus are there, but nothing to worry. You can do this problem very easily. You always believe in the concept, follow it blindly. You observe this is in the form of f of x divided by g of x. G of x cannot be equal to 0. And one more thing, this denominator is in under root. So whatever is there, this expression, what is this expression? Modulus of step mod x minus 1 minus 5 is greater than or equal to 0. This is in under root, na? We must write greater than or equal to 0. But as this expression is in the denominator cannot be equal to 0, I'll write strictly greater than 0. Now you take minus 5 to other side. Modulus of step mod x minus 1 greater than 5. We know this formula. Mod x is greater than a. Then you can write like this: x is less than minus a, or x is greater than a. I'll use this formula. See, modulus of some expression greater than a, mod x greater than a. Just I applied this formula here. I consider this as some x. Now I need to find for what x values this inequality holds good. See, this step of some expression. Step of some expression is less than minus 5. That means you take any number here, less than minus 5. You take any number here. Suppose this is step minus 5.1. Step minus 5.1 is what? Step minus 5.1 is minus 6. Is minus 6 is less than minus 5? Yes, minus 6 is less than minus 5. So what value satisfy this condition? If this value is less than minus 5, so this value is less than minus 5, then this inequality holds good. I hope you are understanding. And you see this one, step mod x minus 1 greater than 5. For what values of this expression this step will be greater than 5? You observe here, if I take this value as 5.9, step 5.9 is what? Step 5.9 is 5 only. Is 5 is greater than 5? No. So this expression I can take like this, mod x minus 1 must be greater than or equal to 6. Step 6 is 6 only, na? 6 is greater than 5. It is true. If I take this expression as 6.1, step 6.1 is 6. 6 is greater than 5. So this inequality holds good when this expression is greater than or equal to 6. Now what I'll do, I'll take this minus 1 to other side. Then what you will get? Minus 4, right? Or you observe this one, mod x is, you take minus 1 to other side, mod x greater than or equal to 7. For what values of x? Modulus of x is less than minus 4. You know that modulus of x always gives a positive real number. 0 is also possible. But you will never get mod x value less than minus 4. Modulus of x less than minus 4. Is it possible? There is no x value which satisfies this condition. You take any real x value, that value is positive or 0. It never be negative. So this case is not possible. So for this inequality, we won't get any x value. No x value satisfies this inequality. Now come to this. Modulus of x greater than or equal to 7. You written this formula here na? Modulus of x greater than or equal to a means x less than or equal to a or x greater than or equal to a. Modulus of x greater than or equal to 7. What I can write here? I can write x less than or equal to minus 7 or x greater than or equal to 7. So what are the x values satisfying both the condition means there is no x value satisfying this condition. What are the x values satisfying this condition means these are the x values satisfying this condition. So for these x values, this function is defined. That's why this is the domain of this function. I hope you understand this class. Dear friends, finding domain of a function is a little difficult thing only. But with practice, we can overcome this difficulty. In next class, I am going to do the problems finding domain of a function which involves with trigonometric functions. In this class, we are going to do problems on domain of a function which are involving with trigonometric function. To understand this class, it is important you must know domains and range of all trigonometric functions. So first we will learn what are domain and ranges of all trigonometric functions. You observe this sin x. What is domain and range of sin x? If you observe the graph of sine function, then what I am explaining that you can understand very easily. What is the domain of sine function? Domain of sine function is all real number. Whatever x value you take, sin x is defined. What about range of sine function? When you observe the graph of sine function, you can see that sine function graph always lies in between minus 1 and plus 1. So range of sine function is closed interval minus 1 comma 1. When sin x equal to 0, what are the x values? X may be 0 degrees. Sin 0 degrees is 0. Sin pi is 0. Sin 2 pi is 0, sin 3 pi is 0, sin 4 pi is 0. Not only pi, sin of minus pi is also 0, sin of minus 2 pi also 0, like that you will get plus or minus. So in general, what I can write here, this is of the form pi, 2 pi, 3 pi, 4 pi, minus 2 pi, minus 3 pi, minus 4 pi, like that na. I can write that x equal to n pi where n is an integer. So when sin x is 0, at that time, what are x values? X is n pi. You keep this point in your mind. We use this very frequently. So what you learned? You learned that domain of sin x is all real numbers. Range of sin x is closed interval minus 1 comma 1. And whenever sin x is 0, then x equal to n pi. Now, cos x function. What is domain and range of cos x function? For any real x value, cos x is defined. So domain of cos x function is all real numbers. What about its range? If you observe the graph of cos x function, its values always lies in between minus 1 and plus 1. Cos x function range also closed interval minus 1 comma 1. And what is the one more point you need to keep in your mind? When cos x is 0, at that time what are the x values? X is pi by 2. Cos pi by 2 value 0. You can calculate these things. Cos 3 pi by 2 also 0. cos 5 pi by 2 also 0, cos 7 pi by 2 also 0. So what happened here? 1 into pi by 2, 3 into pi by 2, 5 into pi by 2, 7 into pi by 2. What you identified? Odd number into pi by 2. When x is odd number into pi by 2, at that time cos x is 0. In general, how I can write this? I'll write like this. Odd number generally we denote like this. 2n plus 1 represents odd number. 2n plus 1 into pi by 2. Here what is n? N is an integer. So what you learn about cos x? You learn that domain of cos x is all real numbers. Range of cos x is closed interval minus 1 comma 1. When cos x is 0, at that time x values will be odd multiple of pi by 2. 2n plus 1 into pi by 2. These things we use frequently. Tan x. What is domain and range of tan x? Tan x can be written as sin x by cos x na? You observe it is of the form f of x divided by g of x. This denominator cannot be equal to 0. Cos x cannot be equal to 0. Just now we learn for what values of x cos x is 0. Whenever x is odd multiple of pi by 2. Whenever x is odd multiple of pi by 2. In that case, cos x is 0. So, cos x not equal to 0 means x cannot be equal to 2n plus 1 into pi by 2. So, this tan x is defined for all real numbers, but this is not defined when x is odd multiple of pi by 2. What about range? Range of tan function. If you observe the graph of tan function, range is all real numbers. It can give any real value. So what you learn? You learn that domain of tan x is r minus 2n plus 1 into pi by 2 and range of tan x is all real numbers. Cot x. Cot x can be written as cos x by sin x. Here whenever sin x is 0, then this denominator is becoming 0, then cot x is not defined. So this sin x, when this sin x is 0, just now we learn at this point, when sin x is 0, at that time x is n pi. So here sin x cannot be equal to 0. That means x cannot be equal to n pi. So what is domain of cot x? Domain of cot x is all real numbers except n pi. What is range of cot x? If you observe the graph of cot x, you can understand what I am saying here. You can see that graph. Cot x will gives you any real number based on x value. So range of cot x is all real numbers. So domain of cot x is r minus n pi and range of cot x is all real numbers. It is important you need to memorize all these points. You observe domain of secant x. Secant x can be written as 1 by cos x. If the denominator is 0, then this is not defined. When cos x is 0, cos x is 0 when x is odd multiple of pi by 2. So what is domain of secant x? Domain of secant x is all real numbers except odd multiple of pi by 2. I hope you are understanding. So domain of secant x is r minus 2n plus 1 into pi by 2. And what is range of secant x? This is important. You can understand these things when you know the graphs of these functions. I already done a video on graphs of all trigonometric functions. If you want, you can check that video. Or else in case if you have in your textbook, you can find these graphs. Range of secant x is all real numbers except the numbers in open interval minus 1 comma 1. You see the graph of secant x, you can observe, you don't find the graph of secant x in between minus 1 and plus 1. Whatever x value you take, secant x always gives a number which is greater than 1 or which is less than minus 1. You will never get secant x value in between minus 1 and plus 1. So domain of secant x is all real numbers except odd multiple of pi by 2 and its range is all real numbers except open interval minus 1 comma 1. Now, last trigonometric function, that is cosecant x. What is domain of cosecant x? Cosecant x can be written as 1 by sin x. Sin x cannot be equal to 0. When sin x is 0, when sin x is 0, then x equal to n pi. So, all real numbers except n pi. What is n here? N is an integer. So, domain of cosecant x is r minus n pi. And what about its range? If you observe the graph of cosecant x, then you can easily say that range of cosecant x is r minus open interval minus 1 comma 1. So these are the domains and ranges of all 6 trigonometric functions. To understand the problems on domain of a function which are involving with trigonometric functions, this knowledge is compulsory. You observe this question number 31. We need to calculate domain of this function, square root of cosecant x minus 1. We know that whatever the expression is there in under root, it must be greater than or equal to 0. So here what I'll write that cosecant x minus 1 is greater than or equal to 0. You take 1 to other side, then what you will get? Cosecant x greater than or equal to 1. Now we need to find for what x values this inequality holds good. Just now we learned that cosecant x value always greater than or equal to 1 or less than or equal to minus 1. Cosecant x greater than or equal to 1 means all values are positive. Cosecant x is positive in which quadrants? In trigonometry we learned that cosecant x is positive in first quadrant and second quadrant. First quadrant, second quadrant, I can write like this: open interval 0 comma pi. Why I written open interval 0 comma pi? So here cosecant 0 is not defined. Cosecant pi also not defined. Cosecant x is positive in first quadrant and second quadrant. So first quadrant to second quadrant range is what? 0 to pi. I written 0 to pi. Here I written open interval. Why? Because cosecant 0 is not defined. Cosecant pi also not defined. 1, 2, 3, 4. Again 5, 6. 5, 6. Fifth quadrant, sixth quadrant, which is same as first quadrant, second quadrant. That means fifth quadrant means 2 pi. 2 pi to 3 pi. Please try to understand. 2 pi to 3 pi. Again, see 4 pi comma 5 pi. In general, how we will write this? We will write like this. X belongs to, you see here, even number into pi. 0 can be written as 0 into pi. 0 is even number. Even number into pi. Even number into pi. I'll write like this. Open interval. Open interval, even number into pi, and this is observe odd number into pi, 1 into pi, 3 into pi, 5 into pi. We know that odd number is denoted by 2n plus 1, 2n plus 1 into pi. So what is domain of this function? Open interval 2n pi comma 2n plus 1 into pi. Here what is n? N is an integer. You observe this question number 32, we need to find domain of this function. You can see here sum of two functions is there. So we know that if d1 is the domain of f of x, d2 is the domain of g of x, domain of f of x plus g of x is d1 intersection d2. So first I'll calculate domain of this function, next I'll calculate domain of this function, later I'll do their intersection to calculate domain of this entire function. Domain of this function, as this is in under root, whatever the expression inside the root is there, that must be greater than or equal to 0. So here what I'll do, I'll multiply this inequality with negative number. We know that for an inequality, if we multiply with a negative real number, this inequality sign changes. When I multiply with minus, this will become cos x less than or equal to 0. Multiply this complete inequality with minus, this greater than or equal to changes to less than or equal to. Less than 0 means negative. Cos x is negative in which quadrants? Cos x is negative in second quadrant as well as in third quadrant. So what I can write here, x belongs to closed interval because equality is there here, closed interval, second quadrant to third quadrant. I can write like this, x belongs to closed interval pi by 2 comma 3 pi by 2. Cos x is negative in second quadrant and third quadrant, pi by 2 to 3 pi by 2, that means 90 to 270 degrees, that is second quadrant, third quadrant. And why I written closed brackets? Because equality is there. I know that cos pi by 2 is 0. I know that cos 3 pi by 2 value is 0. That's why I written x belongs to closed interval pi by 2 comma 3 pi by 2. So domain of this function is this one. Now I'll calculate domain of this one. This is in under root. Now whatever expression is there in under root, that must be greater than or equal to 0. Here sin x greater than or equal to 0 means sin x is positive. Sin x is positive in which quadrant? It is positive in first quadrant as well as in second quadrant. So what I can write here, x belongs to first quadrant and second quadrant, na closed interval 0 comma pi. Because why I written closed interval? Because equality is there. I know that sin 0 is 0 and sin pi is also 0. Now I calculated domain of this, I calculated domain of this. To calculate domain of this full function, what I need? I need intersection of these two sets. This is second quadrant, third quadrant. This is first quadrant, second quadrant. Understanding, this is second quadrant, third quadrant, this is first quadrant, second quadrant. In these two, which quadrant is common? Second and third, first and second. Second quadrant is common in both. So when we do their intersection, I'll get the second quadrant. Second quadrant means what? Pi by 2 to pi. So closed interval pi by 2 comma pi. This is domain of this function. I hope you understand this. You observe this question number 33. Domain of this function. Whatever the expression is there in under root, that must be greater than or equal to 0. That means logarithm of 1 divided by modulus of sin x, this must be greater than or equal to 0. Log of something is there. That means this expression must be greater than 0. 1 divided by mod sin x, this must be greater than 0 because logarithm is defined for positive real numbers only. And one more thing here, this is of the form f of x divided by g of x. This denominator cannot be equal to 0. That means modulus of sin x cannot be equal to 0. Here in the base nothing is given. That means common logarithm will be there. That means base 10 will be there. As per the definition of logarithm, you take 10 to this side. As 10 is greater than 1, inequality remains same. You will get like this. 1 divided by modulus of sin x is greater than or equal to 10 power 0 is 1. I hope you are understanding. 1 divided by modulus of sin x greater than 0 and modulus of sin x not equal to 0. You observe this is greater than or equal to 1. This is greater than 0. Both are same expression only. So when I take intersection of these two, what I will get? 1 divided by modulus of sin x greater than or equal to 1 and modulus of sin x not equal to 0. Now I need to find x values which satisfies both the conditions. So this is positive, as modulus is there, this expression is also positive and this value is not equal to 0. As both are positive, I can take its reciprocal. When both are positive, when I take its reciprocals, inequality changes. What is this? 1 by mod sin x reciprocal is mod sin x. Mod sin x. See, when I write its reciprocal, inequality changes. Greater than or equal to changes to less than or equal to 1. You see this modulus of sin x less than or equal to 1. We learned this. Modulus of x less than or equal to a. Whenever modulus of x less than or equal to a, then we will write like this. Minus a less than or equal to x less than or equal to a. You just apply this formula to this. Then what you will get? You will get minus 1 less than or equal to sin x less than or equal to 1. Now the point is, for what values of x, sin x value lies in between minus 1 and plus 1. For what values of x, sin x value lies in between minus 1 and plus 1. So for what x values satisfies this inequality? All real numbers satisfies this inequality. Now you see here, modulus of sin x not equal to 0. Whenever sin x is 0, then modulus of sin x is 0. When sin x is 0, what is x? X is n pi. I hope you are understanding. Where n is an integer, we discussed this in the beginning. When sin x equal to 0, x is n pi. Okay, now we need the x values which satisfies both the conditions. I will get all real numbers except n pi. I hope you are understanding. So what is domain of this function? Domain of this function is all real numbers except n pi, where n is an integer. I hope you understand this. You observe this question number 34. By seeing this problem, you may worry because here greatest integer function is there. But actually this problem is easy. You always believe in the concept and apply the concept. You observe here, this is f of x into g of x. If d1 is the domain of f of x, d2 is the domain of g of x, the domain of f of x into g of x is d1 intersection d2. d1 intersection d2. So what I'll do, I'll calculate domain of this function. Next I'll calculate domain of this function. I'll do their intersection. Now domain of this part. Step x domain is what? Greatest integer function domain is what? Greatest integer function is defined for all real numbers. So it is very easy. Domain of step x is all real numbers. Now I'll calculate domain of this part. You observe this is sin of something. Sin x domain is what? Sin x domain is all real numbers. So this is defined for all real numbers. But here it is of the form f of x by g of x. Whatever is there in the denominator, that cannot be equal to 0. That means step x plus 1 cannot be equal to 0. Now I need to find the x values for which this expression is not equal to 0. First thing, when step x will be 0? When step x will be 0? Whenever I take x value in closed interval 0 comma open interval 1. You take any number in this interval, substitute in this. Step 0.9 is 0. Step 0.1 is 0. That means whatever expression is there, that cannot be in this interval. When I take this x plus 1 value in this interval, then this expression will become 0. First I'll calculate for what x values this expression is 0. Later I'll remove from real numbers. Okay, now this complete inequality you subtract with 1. 0 minus 1, that is minus 1, less than or equal to x plus 1 minus 1. Plus 1 minus 1 will get cancelled, x less than 1 minus 1. 1 minus 1 is 0. Domain of sin x is all real numbers. But we need to eliminate the numbers for which step x plus 1 is 0. So from real numbers, I need to remove this interval minus infinity to open interval minus 1 union. You see in this minus 1 is not included because minus 1 is there here. When I write x is minus 1, this will become 0. Union 0 to infinity. So domain of this part is open interval minus infinity comma minus 1 union 0 to infinity. Domain of this is all real numbers. Domain of this is this I got. And you see here what I need finally. Domain of this entire function is intersection of these two intervals. This is all real numbers. This is not all real numbers. This set is subset of this. When A is subset of B, A intersection B is A only. So when I do intersection of these two, again you will get this only. I hope you are understanding. D1 intersection D2 is what? Minus infinity comma minus 1 union 0 comma infinity. So domain of this function is this. I hope you understand this. These problems initially you may feel difficult, but you can overcome this difficulty only with practice. In this class, we are going to do another 5 problems on domain of a function. In this class also, you can observe in all the problems, trigonometric functions are there. So, in this class, we are doing problems on domain of a function involving with trigonometric functions. You may feel these are little confusing. So, have patience, watch this video till the end to understand all the things clearly. So, without much delay, let's begin the class. You observe this question number 35. We need to calculate domain of this function, log of cos x base x. Here, logarithm is there, na? Whatever this expression is there, that must be greater than 0. Cos x must be greater than 0 because logarithm is defined for positive real numbers only. What about this base? This base is also greater than 0. And base value cannot be equal to 1. Now you need to find x values which satisfies all 3 conditions. Cos x greater than 0, that means cos x is positive. Cos x is positive in which quadrants? Cos x is positive in first quadrant, cos x is positive in fourth quadrant. First quadrant, fourth quadrant, interval we can write like this. X belongs to open interval minus pi by 2 comma pi by 2. I hope you understand. 0 to pi by 2 is first quadrant. Fourth quadrant can be written as minus pi by 2 to 0, fourth quadrant, in anti-clockwise direction. So, when cos x is greater than 0, x values lies in open interval minus pi by 2 comma pi by 2. Now, what are the other things we have? X greater than 0 and x value not equal to 1. What I will do first, I will do intersection of these two. If I do intersection of these two, here x greater than 0. In this, negative values are there, positive values are there. When I do intersection of these two, what I will get? X belongs to open interval 0 comma pi by 2. You observe this interval is present in this as well as in this also. So when I do intersection of these two, I will get like this. And x cannot be equal to 1. 0 to pi by 2 means 0 to 90 degrees. Here 1 means if we consider 1 as 1 radian, 1 radian is approximately equal to 57 degrees. 57 degrees are present in this interval. Yes, 57 degrees present in this interval. But x cannot be 1. So, from this interval, I need to remove 1. So, what is domain of this function? Domain of this function is open interval 0 comma pi by 2 except 1. Whenever we take x value in this interval, this function is defined. That's why this is known as domain of this function. I hope you understand this. You observe question number 36, we need to calculate domain of this function. Here cos of something is there. We know that cos x is defined for all real numbers. So nothing to worry. This can be any real number. Now you observe here log of something is there. We know that logarithm is defined for positive real numbers only. So whatever this expression is there, that must be greater than 0. Root over 16 minus x square divided by 3 minus x must be greater than 0. Why? Because logarithm is defined for positive real numbers only. And one more thing, in this square root is there. We know that whatever the expression is there in square root, that must be greater than or equal to 0. Here 16 minus x square must be greater than or equal to 0. But when I take equal to 0, there is a problem. When this expression is 0, this will become log 0. Log 0 is not defined. That's why here you need to keep with strictly greater than 0. 16 minus x square strictly greater than 0. It cannot be equal to 0. And one more thing, this is of the form f of x divided by g of x. If g of x is 0, then this function is not defined. So 3 minus x cannot be equal to 0. Now we need to find x values which satisfies all three conditions. You come to this one. Root over 16 minus x square is always positive. There is a chance of 0, but it will never be 0 because 16 minus x square is not 0. Please try to understand this. Whatever the expression in under root, you observe the range of root x. You will get all positive real numbers including 0. You won't get 0 here because 16 minus x square value is greater than 0. Clearly this is positive. Okay, what we want here, this total expression is greater than 0. This total expression is positive. We know that this whole thing, numerator is positive. Denominator must be positive. Numerator is positive, denominator is positive, then only this whole thing is positive. I hope you are understanding. This total inequality will be true only when 3 minus x is greater than 0. You see here, I need x values which satisfies this condition. So I'll multiply this complete inequality with minus. Multiply with minus, this 16 minus x square will become x square minus 16. We know that for an inequality, if we multiply with a negative real number, inequality sign changes. This greater than changes to less than 0. 3 minus x not equal to 0 means x cannot be equal to 3. For this inequality, you multiply with minus, this 3 minus x will become x minus 3. When I multiply inequality with negative real number, inequality sign changes, greater than changes to less than. From this, what is x? X is less than 3. Now to find the x values which satisfies this inequality, I'll write this in the form of x minus a into x minus b so that I can easily calculate. X square minus 16 can be written as x plus 4 into x minus 4. X plus 4 into x minus 4 less than 0. You mark them on the number line. You equate this to 0. You will get x equal to minus 4. You mark it on the number line. You equate this to 0. You will get x equal to 4. You mark it on the number line. To find x values which satisfies this inequality, by using wavy curve method, in the rightmost corner you keep plus and then alternate symbols, minus, plus, like this. Less than 0 means I want negative sign, where in this interval this expression is negative. So x belongs to open interval minus 4 comma 4. And here this is as usual, x cannot be equal to 3. Now I need to find intersection of all these three sets. To find x values which satisfies all three conditions, I'll mark them on the number line. You observe here minus 4, 3, 4. Three numbers are there. Mark them as per number line order. Minus 4, 3, 4. Okay, I'll mark this set. X less than 3. Open interval. Strictly less than 3 na? Open interval. X less than 3 means all these values. All these values are less than 3. Now, open interval minus 4 comma 4. That means this part. Open interval minus 4 comma 4. What is intersection of these two? What is intersection? This is first set. This is second set. Intersection of these two is this. So x belongs to open interval minus 4 comma 3. I hope you are understanding. Intersection of these two sets is x belongs to open interval minus 4 comma 3. In this 3 is there. In this interval 3 is there. This is open interval 3 na? That means 3 is not included. See, x is not equal to 3. In this 3 is not there. So no problem. So what are the x values which satisfies all three conditions? This is the interval which satisfies all three conditions. So when I take x value in this interval, this function is defined. That's why this is known as domain of this function. I hope you understand this. You observe this question number 37. We need to find domain of this function f of x equal to 1 divided by 1 minus tan x. This is of the form f of x divided by g of x. This g of x cannot be equal to 0. If denominator is 0, then this function is not defined. So 1 minus tan x not equal to 0. From this, what I can write? I can write that tan x cannot be equal to 1. Okay, tan x cannot be equal to 1 can be written as tan pi by 4 na? Tan x cannot be equal to tan pi by 4. We know the general solution for trigonometric equation tan theta equal to k. When tan theta equal to k, theta is n pi plus pi by 4. Here x not equal to, because here not equal symbol is there na? X not equal to n pi plus pi by 4. where n is an integer. And one more point you need to keep in your mind, here tan x is there. Tan x is not defined for all real numbers. What is the domain of tan x? Domain of tan x is all real numbers except odd multiples of pi by 2. This we learned in last class. So here x cannot be equal to odd multiple of pi by 2. I hope you are understanding. X cannot be equal to odd multiple of pi by 2. Suppose tan pi by 2 not defined, then this whole thing is not defined. Tan 3 pi by 2 not defined, that means this whole thing is not defined. So this x value cannot be equal to odd multiple of pi by 2. What I'll do, I'll simplify this little bit. This whole expression you multiply with pi by 2, what you will get? X cannot be equal to n pi plus pi by 2. So x cannot be equal to n pi plus pi by 2. X cannot be equal to n pi plus pi by 4. So this function is defined for all real numbers except the values of x. If x is of this form, this function is not defined. If x is of this form, then this function is not defined. So what I'll do, I'll write its domain. What is domain of this function? Domain of this function is all real numbers, but for these values, this function is not defined. X cannot be equal to n pi plus pi by 4. At the same time, x cannot be equal to n pi plus pi by 2. In this, n is an integer. If I take any real number in this set, then this function is defined. That's why this is known as domain of this function. What is domain of a function? For what values of x the function is defined, that is known as domain of the function. You observe this question number 38. We need to find domain of this function. 1 divided by 1 plus 2 sin x. This is of the form f of x divided by g of x. This denominator cannot be equal to 0. So 1 plus 2 sin x cannot be equal to 0. From this, what is sin x? Sin x cannot be equal to, take 1 to this side and 2 to the denominator. Sin x cannot be equal to minus 1 by 2. Now I'll use trigonometric equations to write the general solution for what x values sin x is not equal to minus 1 by 2. This minus 1 by 2 can be written like this. Sine of minus 30 degrees. Sine of minus pi by 6. See here, sine of minus pi by 6 is minus sine pi by 6. Sin pi by 6 means sin 30 degrees. Sin 30 degrees value 1 by 2. So this minus 1 by 2 I can write like this. From trigonometric equations, we know that whenever sin theta equal to k, its general solution is n pi plus minus 1 whole power n into alpha, where alpha is the principal solution. So what I can write here, I can write x cannot be equal to n pi plus minus 1 whole power n into alpha. What is alpha? Alpha is minus pi by 6. X value cannot be equal to this. In place of this minus pi by 6, you can write pi minus theta also. Pi minus theta. Pi minus, what is theta here? Minus pi by 6. What you will get here? Minus of minus plus 6 pi plus pi by 6 is 7 pi by 6. So you can answer, you can write like this. Or you can write like this also. X not equal to n pi plus minus 1 whole power n into 7 pi by 6. Answer you can write like this or you can write like this also. I hope you understand this. You observe this question number 39. The function f of x is defined on closed interval 0, 1. What they are saying, the function f of x is defined on closed interval 0, 1. What it tells? F of x is defined on closed interval 0, 1 means what it tells? Whatever x values are there, they lie in this interval. That means 0 less than or equal to x less than or equal to 1. Okay. Now what they are asking, find the domain of f of tan x. In place of x here tan x is there. That means tan x value lies in between 0 and 1. So what I can write here? Closed interval 0 less than or equal to tan x less than or equal to 1. I hope you understand. As they given f of x is defined on closed interval 0, 1, whatever is there here that lies in between 0 and 1. Here f of tan x, in place of x, here tan x is there. That means tan x values lies in between closed interval 0, 1. Now this 0 can be written as tan 0, okay, less than or equal to tan x less than or equal to 1. 1 can be written as tan pi by 4. Now what I'll do, I'll apply tan inverse to this. We know that tan inverse of tan theta is theta when theta belongs to open interval minus pi by 2, pi by 2. So when you apply tan inverse to this, tan inverse of tan 0 is 0 less than or equal to tan inverse of tan x is x less than or equal to tan inverse of tan pi by 4 is pi by 4. That means what is the domain of this function? Domain of f of tan x is closed interval 0, pi by 4. So domain of f of tan x is closed interval 0, pi by 4. This is the interval in first quadrant. In case if they are asking in general form, then how you will write? To write this into general form, you see when tan x is 0, then x is what? X is n pi. When tan x is 0, x is n pi. Less than or equal to x less than or equal to. When tan x equal to 1, what is its general solution? Tan x equal to 1. Tan theta equal to k, general solution is n pi plus alpha. When tan x equal to k, its general solution is what? N pi plus pi by 4. N pi plus pi by 4. You can understand this easily if you know the knowledge of trigonometric equations in trigonometry chapter. So, if they are asking domain of this function in first quadrant, means we will write closed interval 0 comma pi by 4. If they are asking in general, what is the domain of this function, means this is domain of this function. I hope you understand this class. Doing problems on domain of a function initially confuses, but once you got grip on the concept, then you can do these problems very easily. Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is 9th class on domain of a function video series. In this class, we are going to do the problems on domain of a function involving with inverse trigonometric functions. To understand today's problems, it is important you must know domain and ranges of all inverse trigonometric functions. So, first we will learn what are domain and ranges of all inverse trigonometric functions, and then we are going to do 4 problems in this class. You observe in all 4 problems inverse trigonometric functions are there. In this class, we are going to do all these 4 problems. Please drop a like to this video so that I'll get more energy to create many videos. Without much delay, let's begin the class. You observe here, what is domain of sin inverse x? Domain of sin inverse x is closed interval minus 1 comma 1. Whenever this x value is closed interval minus 1 comma 1, at that time sin inverse x is defined. And what is range of sin inverse x? Range of sin inverse x is closed interval minus pi by 2 comma pi by 2. So, domain of sin inverse x is closed interval minus 1 comma 1. Range of sin inverse x is closed interval minus pi by 2 comma pi by 2. What is domain of cos inverse x? Domain of cos inverse x is also closed interval minus 1 comma 1. It is easy to memorize. Domain of sin inverse x is closed interval minus 1 comma 1. Domain of cos inverse x is closed interval minus 1 comma 1. What about range of cos inverse x? Range of cos inverse x is closed interval 0 comma pi. Range of cos inverse x is closed interval 0 comma pi. What is domain of tan inverse x? Domain of tan inverse x is all real numbers. What about range? Range of tan inverse x is, you observe here. Here closed interval is there, na? You write open interval minus pi by 2 comma pi by 2. These things you need to memorize. Domain of tan inverse x is all real numbers. Range of tan inverse x is open interval minus pi by 2 comma pi by 2. You already learned 3 inverse trigonometric functions, domains and range. Only 3 more remaining. Domain of tan inverse x, domain of cot inverse x, both are same. Domain of cot inverse x is all real numbers. What about range of cot inverse x? You observe this. Here closed interval is there, na? Here you write open interval. Very simple, little bit of practice is needed. So, domain of cot inverse x is all real numbers. Range of cot inverse x is open interval 0 comma pi. Domain of cosecant inverse x is r minus open interval minus 1 comma 1. This is the easy way of saying domain of cosecant inverse x. Some people will write open interval minus infinity to closed interval minus 1 union closed interval 1 to infinity. That is also correct, but easy way of memorizing is all real numbers except the values in open interval minus 1 comma 1. Now range of cosecant inverse x. Range of sin inverse x is there, na? You write that as it is. Closed interval minus pi by 2 comma pi by 2. Just to memorize, I am giving this trick. So what you will do, you just remove 0. That's it. Range of cosecant inverse x, first you write this as it is and then just remove the 0. So range of cosecant inverse x is closed interval minus pi by 2 comma pi by 2 except 0. Secant inverse x domain. Secant inverse x domain, cosecant inverse x domain, both are same. See, feel happy that, domain of these two are same, domain of these two are same, domain of these two are same. Buy one get one type. If you learn one, another one easily you can memorize. Range of secant inverse x. You write by using this cos inverse x. Cos inverse x range you write as it is first. Same write this as it is and just you remove pi by 2. These are the domains and ranges of inverse trigonometric functions. You need to memorize all these things to understand the problems on domain of a function involving with inverse trigonometric functions. You observe this question number 40. We need to find domain of sine inverse of 2x plus 1 divided by 3. We know that sine inverse of x is defined in closed interval minus 1 comma 1. So what I'll write here, minus 1 less than or equal to this expression 2x plus 1 by 3 less than or equal to 1. Because domain of sine inverse x is closed interval minus 1 comma 1. Closed interval, that's why I written equality here. Now I need to find the x values which satisfies this inequality. I'll multiply this complete inequality with 3. As 3 is positive number, this inequality remains same. Multiply with 3, minus 3 less than or equal to, when I multiply here with 3 will get cancelled. What you will get here? 2x plus 1 less than or equal to 1 into 3 is 3. My intention is to get the x value. Here 2x plus 1 is there. Na? What I'll do, for this complete inequality, I'll subtract with 1. When I subtract with 1, inequality remains same. So minus 3 minus 1, that is minus 4 less than or equal to 2x plus 1 minus 1. Plus 1 minus 1 will get cancelled. 2x less than or equal to 3 minus 1. 3 minus 1 is 2. I hope you are understanding. What I'll do, this complete inequality, I'll divide with 2. 2 is a positive number. Na? When we divide with a positive number, inequality remains same. Divide this complete inequality with 2. Why we are dividing with 2? Just to get the x value. When I divide this with 2, minus 4 divided by 2 is minus 2 less than or equal to x less than or equal to 1. So when x value is in this interval, then this function is defined. So what is domain? Domain of sine inverse of 2x plus 1 divided by 3 is closed interval minus 2 comma 1. Domain of cos inverse of root 2x. What is domain of cos inverse x? Domain of cos inverse x is closed interval minus 1 comma 1. So this expression must be in closed interval minus 1 comma 1. So I'll write that minus 1 less than or equal to root 2x less than or equal to 1. And one more thing, in this square root is there. Square root is there. We learned from earlier classes, whatever the expression is there in under root, that must be greater than or equal to 0. I need to find x values which satisfies both the conditions. You observe here what they given, minus 1 less than or equal to root 2x less than or equal to 1. What do you know about root 2x? Root 2x value always positive, there is a chance of 0. You will never get that root of some expression is negative. But here what you got? Root 2x value in between minus 1 and plus 1. But it is not possible to get negative values for root 2x. So what I can write, root 2x value definitely in between like this only. Root 2x less than or equal to 1. I hope you understand this. 2x greater than or equal to 0 means take 2 to other side, x is greater than or equal to 0. Here this root x is positive expression, so I can square this. You square this inequality, what you will get? 0 less than or equal to 2x less than or equal to 1. Here root 2x will become 2x. Divide this complete inequality by 2. As 2 is a positive number, this inequality remains same. 0 divided by 2 is 0 less than or equal to x less than or equal to 1 by 2. Now I need to find the values of x for which both the inequalities holds good. This tells you that x value is in closed interval 0 comma 1 by 2. And here x value greater than or equal to 0. In this all x values are greater than or equal to 0 only. Please try to understand. In this all x values are greater than or equal to 0. This set is subset of this. This is the smaller set. This set is subset of this. When A is subset of B, A intersection B is A only. So when I do intersection of these two, I will get this only. So what about domain of this function? Domain is closed interval 0 comma 1 by 2. So whenever I will take x value in this interval, this function is defined. That's why this is known as domain of the function. What is domain of the function? Finding domain of a function is nothing but finding the values of x for which the function is defined. You observe this question number 42. Domain of cos inverse of x minus 3 divided by 2 minus logarithm of 4 minus x base 10. We need to calculate domain of this function. If d1 is the domain of f of x, d2 is the domain of g of x, domain of f of x minus g of x is d1 intersection d2. So to calculate domain of this entire function, first I will calculate domain of this part and then I will calculate domain of this part. Later I will do their intersection to calculate domain of entire function. First I will calculate domain of this function. You observe cos inverse of something is there, na? So cos inverse x domain is closed interval -1, 1 na? So -1 less than or equal to x minus 3 divided by 2 less than or equal to 1, because domain of cos inverse x is closed interval -1, 1. Now I will find x values which satisfies this inequality first. I'll multiply complete inequality with 2. As 2 is a positive real number, this inequalities remain same. Multiply with 2, -2 less than or equal to, when I multiply with 2, 2 will get cancelled, you will get x minus 3 here, less than or equal to 1 into 2 is 2. For this complete inequality, I'll add 3. Add 3, -2 plus 3 is 1 less than or equal to x minus 3 plus 3, that is x less than or equal to 2 plus 3 is 5. I got that domain of this part is closed interval 1, 5. Now I will calculate domain of this part. In this, logarithm is there. We know that logarithm is defined for positive real numbers only. So this expression must be greater than 0. 4 minus x must be greater than 0. Multiply this with minus, what you will get? X minus 4. For an inequality, if you multiply with a negative real number, inequality sign changes. This greater than changes to less than. So what you will get here? You will get x less than 4. So this is domain of this part and this is domain of this part. Now what I need intersection of these two. Every time no need to mark them on the number line. Easily we can guess by seeing these two intervals. Can you tell what is the intersection? Here 1 to 4 is there in this. Please try to understand. So what is intersection of these two? X belongs to closed interval 1. Why I written closed interval? 1 is there in this interval. Equality is there. 1 is there in this interval. 1 is there in this interval also. 1 is present in both. Up to 4. 4 is present in this interval, but 4 is not present here. Open interval 1, 4. So what is domain of this function? Domain of this function is closed 1, open 4. You observe question number 43, domain of this function, sin inverse of x minus 3 divided by root over 9 minus x square. It is of the form f of x divided by g of x. We know that if d1 is the domain of f of x, d2 is domain of g of x, then domain of f of x divided by g of x is d1 intersection d2 such that g of x is not equal to 0. What I'll do first, I'll calculate domain of this part. Later I'll calculate domain of this part and then I'll do their intersection to calculate domain of this entire function. First, domain of sin inverse of x minus 3. As you know that domain of sin inverse x is closed interval -1, 1. Whatever the expression is there here, that must be in between closed interval -1, 1. So -1 less than or equal to x minus 3 less than or equal to 1. To get x values for this complete inequality, I'll add with 3. Add 3, -1 plus 3 is 2 less than or equal to x minus 3 plus 3 is x less than or equal to 1 plus 3 is 4. So the domain of sin inverse of x minus 3 is what? Closed interval 2, 4. Now I will come to this part. While calculating domain of this part, you make sure that this g of x not equal to 0. This part is in under root now. Whatever the expression is there in under root, that must be greater than or equal to 0. But if I consider 0, this denominator part will become 0. So I need to take strictly greater than 0. To get the x values easily, I will write in the form of x square minus a square. Multiply this inequality with negative real number. Then what you will get? You will get x square minus 9. Multiply this complete inequality with minus. When we multiply an inequality with negative real number, inequality sign changes. This greater than changes to less than. -1 into 0 is 0. Now this is in the form of x square minus a square. This 9 can be written as 3 square. So it can be written as x plus 3 into x minus 3 less than 0. I need to find the x values which satisfies this inequality. I will use wavy curve method to find the x values which satisfies this inequality. You equate this to 0, you will get -3. You will equate this to 0, you will get +3. You mark them as per number line order. In the rightmost corner plus and then alternate symbols. Here what I want x values which are less than 0. Less than 0 means negative sign I want. Negative sign is there in this interval. X belongs to, this is strictly less than open interval -3, 3. Domain of this part is this one. So domain of f of x is this one, domain of g of x is this one. Now if I do their intersection, I'll get domain of this entire function. Here to identify its intersection, you can mark these two sets on the number line that what we did in earlier classes, but I want to write the answer directly. You observe here 2 to 4. 2 to 4 is there in this interval. 2 to 3 is there. 2 is present in this. 2 is present in this also. What is domain? Domain is intersection of this part and this part. 2 is present in this. 2 is present here also. So closed interval 2 to 3 is present in this interval. 3 is 2 to 3 present in this interval. In this also 2 to 3 is present, but 3 is not included here. So closed to open 3. So domain of this function is closed to open 3. I hope you understand this. Till now we completed 43 problems on domain of a function video series. In this class I am going to do another 5 problems. Whatever the problems we will do today, in all the problems we are doing domain of a function involving with inverse trigonometric functions. Before going to start this video, please drop a like, which gives me more energy to create many videos. And without much delay, let's begin the class. We need to calculate domain of square root of sin x. You can observe two things here. One is square root, another one is inverse trigonometric function. To calculate domain of this function, whatever the expression is there in under root, that must be greater than or equal to 0. This we learned in previous classes also. And second point, here sin inverse x is there. Na? What is the domain of sin inverse x? In last class, we learned that domain of sin inverse x is closed interval -1, 1. So here whatever x value is there, that must be in between -1 and +1. Otherwise the sin inverse x is not defined. So -1 less than or equal to x less than or equal to 1. Okay. Now I need to find the x values which satisfies both inequalities. For this I'll apply sin on both sides. We know that sin of sin inverse x is x. Sin of sin inverse x is x greater than or equal to sin 0. We know from trigonometry table sin 0 is 0 and -1 less than or equal to x less than or equal to 1. Now what are the x values which satisfies both the conditions? You observe here x greater than or equal to 0. In this you can observe that closed interval 0 to 1 is there in this interval. Closed interval 0 to 1, yes, it is there in this. Closed interval 0 to 1 is there in this, yes, it is there. So when I do their intersection, what I'll get? I'll get its domain. What is the domain of given function? Intersection of these two is closed interval 0 to 1, closed one. 0 is included in both, 1 is also included in both. So domain of root over sin inverse x is closed interval 0, 1. You observe this question number 45, we need to calculate domain of this function. Here three things are there. One is square root, second one sin inverse trigonometric function, third one is log. So to calculate domain of this function, we know that whatever the expression is there in under root, that must be greater than or equal to 0. It means sin inverse of log x base 3. This value must be greater than or equal to 0 because this expression is in under root. Second one, we know that sin inverse x domain is closed interval -1, 1. This log x base 3 lies in between -1 and +1. -1 +1 both are included. And you see log x, logarithm is defined for positive real numbers only. So whatever x we will write here, that must be greater than 0. Now we need to find the x values which satisfies all three conditions. First, what I'll do, I'll apply sin to this on both sides. Sin of sin inverse x is x. So what I'll get here? Here I'll get log x base 3 is greater than or equal to sin 0. We know that sin 0 is 0. Okay. Further, if I simplify this, as per the definition of logarithm, this can be written as x greater than or equal to 3 power 0. 3 power 0. 3 power 0 is 1. I am using logarithm definition here. And one important point, in the base, if the number is in between 0 and 1, when I use this logarithm, at that time inequality changes. As this base is greater than 1, when I take this side 3 power 0, this inequality remains same only. So x greater than or equal to 1. Now come to this. Here again I am going to use logarithm definition. I will take 3 to this side. As this number is greater than 1, when I take this to this side, inequalities remain same. So what you will get? 3 power -1. 3 power -1 is nothing but 1 by 3 less than or equal to, here x will be there, less than or equal to 3 power 1 is 3. And the third condition is what? Third condition is x greater than 0. Now to identify the x values which satisfies all three conditions, you can mark this on the number line, but this is easy only. By observing all these three inequalities, directly we can say. You observe in this closed interval 1 to 3 is there. In this closed interval 1 to 3 is there, 1 is included because equality. Greater than or equal to 1, 3 is also included. You observe in this closed interval 1 to 3 is there, 1 by 3 means 0.3 0.33 something you will get here. That means closed interval 1 to 3 is there in this. In this closed interval 1 to 3 is there, x is greater than 0 means closed interval 1 to 3 is there in this also. So what are the x values? X belongs to closed interval 1 to 3. If I do the intersection of all these, I will get this. So this is domain of this function. If I take any x value in this interval, this function is defined. That's why this is called domain of this function. What is domain of the function? Finding domain of a function is nothing but finding the values of x for which given function is defined. You observe this question number 46, domain of tan inverse of 5x. What is domain of tan inverse of x? Domain of tan inverse of x is all real numbers. So whatever the expression is there, it must be any real number. 5x is a real number because tan inverse x domain is all real numbers. Now whatever expression is there, it must be a real number. As 5x is a real number, x is a real number or not? Yes. If 5x is a real number, then x is a real number. So this function is defined for all real numbers. This is very easy question. Not only tan inverse of 5x. Suppose they given tan inverse of 3x. What is the domain of tan inverse of 3x? Domain of tan inverse of 3x is all real numbers. So domain is all real numbers. This all real numbers you can write like this, or else all the numbers in between minus infinity to plus infinity. This is also represents real numbers. You can write like this or you can write like this also. So domain of tan inverse of 5x is all real numbers. You observe this question number 47, domain of sine inverse of x square by 2. We know that sine inverse x is defined when x value lies in closed interval minus 1 comma 1. So here this x square by 2 value must lies in between minus 1 and plus 1. Then only the sine inverse of x square by 2 is defined. Now I need to find the x values for which this inequality holds good. As what I will do here, to get x values, I will multiply this complete inequality with 2. As 2 is a positive real number, this inequality remains same. Multiply this complete inequality with 2. Minus 2 less than or equal to, when I multiply here with 2, 2 will get cancelled. X square less than or equal to 2. Now I got like this, minus 2 less than or equal to x square less than or equal to 2. You observe here, x square is always positive, there is a chance of 0. So x square values will never be negative. So further I can simplify this little bit. How? 0 less than or equal to x square less than or equal to 2. X square value possibility of 0 or more than 0, but it never be negative. Now I need to find the x values which satisfies this condition. If x is there here, then I can do this problem very easily with the help of wavy curve method. But here x square is there, no problem. We can do it. See here, 0 less than or equal to x means x square greater than or equal to 0. 0 less than or equal to x square means x square greater than or equal to 0. And what is the other one? X square less than or equal to 2. X square less than or equal to 2. Take that 2 to this side. X square minus 2 less than or equal to 0. Now x square greater than or equal to 0. For what x values x square is greater than or equal to 0? You can take x is any real number. You take x is any real number which will be greater than 0 or equal to 0. What are the x values satisfying this inequality? Any real number satisfies this inequality. Okay. And you observe here 2 is there. Na? This 2 can be written as root 2 whole square. 2 can be written as root 2 whole square. Now it is in the form of a square minus b square. What is the formula for a square minus b square? X plus root 2 into x minus root 2 less than or equal to 0. You observe this. This is in the form of x minus a into x minus b. Na? By using wavy curve method, I can easily calculate for what x values this inequality holds good. Now you equate this to 0, you will get x equal to minus root 2. You equate this to 0, you will get x equal to root 2. To calculate x values which satisfies this inequality by using wavy curve method, in the rightmost corner you write plus and then alternate symbols minus plus. Less than or equal to 0. Less than or equal to 0 means I need negative values. This what are the x values satisfies this inequality? Negative sign is there here. X belongs to closed interval. Why closed interval? Because here equality is there. Closed interval minus root 2 comma root 2. So these are the x values which satisfies this inequality. I need the x values which satisfies this condition and this condition. You can observe that this set is a subset of this set. When A is subset of B, then A intersection B is A only. Smaller set we will get. This is the smaller set. This is the subset of this. When I do their intersection, you will get this only. So domain of this function is what? Closed interval minus root 2 comma root 2. So whenever whatever x value you take in this interval, then this function is defined. That's why this is known as domain of the function. You observe this question number 48. We need to calculate domain of this function, sine inverse of log x by 3 base 3. We know that domain of sine inverse x is closed interval minus 1 comma 1. So this value lies in closed interval minus 1 comma 1. That I'll write like this: minus 1 less than or equal to logarithm of x by 3 base 3 less than or equal to 1. And one more thing, here you observe here log is there. We know that logarithm is defined for positive real numbers only. So whatever this expression is there, that must be greater than 0. So x by 3 is greater than 0. Now I need to find the x values which satisfies both inequalities. Here logarithm is there na, directly I will apply logarithm definition. In the base this value is greater than 1 na, so when I apply logarithm definition this inequality remains same. When this base value is in between 0 and 1, at that time inequality changes. Okay, you take 3 to this side, 3 power minus 1. 3 power minus 1 is what? 1 by 3 less than or equal to x by 3 less than or equal to 3 power 1. 3 power 1 is 3. Now what I will do to get the x values, I will multiply this complete inequality with 3. Multiply this complete inequality with 3. 3 into 1 by 3, that is 1 less than or equal to 3 into x by 3, that is x less than or equal to 3 into 3 is 9. So these are the x values which satisfies this inequality. You come to this, and one more thing is there here, x by 3 greater than 0 means what is x? You take 3 to that side, x is greater than 0. So I need the x values which satisfies both the conditions. Closed interval 1 to 9 is a subset of this. As this is a subset of this, when I do their intersection, I will get the smaller set. So what is the intersection of these two sets? Intersection of these two sets is the domain, and the domain is closed interval 1 comma 9. Or else simply you can say this is the domain of this function. Whenever I take x values in this interval, this function is defined. That's why this is known as domain of this function. What is domain of a function? You always keep this in your mind. Finding domain of a function is nothing but finding the values of x for which the function is defined. Hello everyone, I am Balaji Rao. Welcome to BR Max class. In this class, we are going to discuss about range of a function. Till now, I did 10 videos on domain of a function video series. I'll give that link in cards or in the description. Those videos will be useful to understand range of a function. In this class, I am going to discuss what is range of a function. I'll take 10 standard functions. I'll draw their graphs and I'll discuss their domain and range with the help of graph. These standard functions graphs you need to memorize. If you want to be good in functions chapter, it is important you need to memorize the graphs of standard functions like modulus function, log x function, root x function. All those things we are going to discuss in this class. So before going to start this video, please drop a like for this video. Without much delay, let's begin the class. You observe this diagram, there is a relation f from a to b. Is this relation is function or not? How to decide? What is the definition of function? For every element in set A, there exists only one element in set B. Right? Our simple words is what? Every element in set A is used, it is used only once, then we say it is a function. You see here, A is used, it is used only once. B is used, it is used only once. C is used, it is used only once. So what happened here? Every element is used, it is used only once. So I say that it is a function. Or else for every element in set A, there exists only one element in set B. That's why it is a function. First thing, f from A to B is a function. If f from A to B is a function, then set A is called domain. This set is called domain. Set B is called codomain. Set of all images of set A is called range. We already learned that domain is nothing but for what values of x the function is defined, that is known as domain of the function. Here it is defined for these three values. So domain of this function is what? Domain of this function is ABC. In simple words, if f from A to B is a function, then set A is called domain. So this is domain of this function. After domain, if f from a to b is a function, then set b is called codomain. This is set b now. This set b is called codomain. So this is codomain of this function. What is range? What is the definition of range? If f from a to b is a function, then the set of all images of set A is called range. What is image of A? Image of A is 4. Image of B is 3. Image of C is 1. The set of all images of this set. So that means what you will get? 1, 3, 4. You observe here, domain is ABC. Codomain is what? 1, 2, 3, 4, 5. What is range? Range is 1, 3. Now, I am going to take some standard functions. I'll discuss the domain of that function, range of that function with the help of graph. These graphs you need to memorize. You observe here modulus of x. What are domain and ranges of modulus function? You can easily say its domain and range if you can draw the graph of mod x function. What is the graph of mod x function? Graph of mod x function is victory symbol. In textbook, the graph of modulus function is given. This is graph of modulus function. To remember it easily, this is the shape of V, symbol for victory. Okay, victory symbol. What is the domain of this function? Generally, to calculate domain, we will observe the x-axis. To calculate range, we will observe y-axis. You observe this function is defined for all real numbers. Suppose if I take an x value here, respective y value exists or not. So this function is defined for all real numbers. What is domain of modulus function? Domain of modulus function is all real numbers. Now range. From the graph, where we need to observe what values the function gives, that is range. You observe this graph. This graph is in first quadrant as well as in second quadrant. It is not in third and fourth quadrants. That means this graph is on positive y-axis only. So range of this function is what? Range of this function is positive y-axis. Here 0 is also included. You try to understand. When I take x is 0, modulus of 0 is 0 na? That means mod x gives 0. That will be included in its range. Modulus of minus 3 is 3. Modulus of 1 by 2 is 1 by 2. Modulus of minus 1 by 2 is also 1 by 2. So, what I am trying to say, the range of modulus function is all positive real numbers including 0. The range of modulus function is closed interval 0 to open interval infinity. You observe here, root x. Square root of x. What is domain and range of square root of x? Square root of x graph also we can remember very easily. If you know the graph of root x, you can easily write its domain and range. You memorize the graph of root x, the graph of root x will be like this. You observe, this is graph of root x. Domain, how you will find? By observing the x-axis, we will say its domain. How we will say its range? By seeing its y values. By seeing y-axis, we will say its range. Now, you observe, this graph is only in first quadrant. This graph is only in first quadrant means x is also positive, y is also positive. Correct? Here, is it possible that root x will be 0? Yes, possibility is there. Root 0 is what? Root 0 is 0 na? So, domain of this function is closed 0 to open infinity. That is the domain of the function. What is range of this function? You need to observe the y-axis for the range. Whatever x value, positive x value you take, respective y value comes. So, what is range? What values root x gives? That is range of the function. Root 0, 0. So, you can observe from the graph, this range is always positive. There is a chance of 0. So, what is range of root x? Range of root x is closed interval 0 to open infinity. Closed interval 0 to open infinity. I hope you are understanding. You observe this. What is this? This is greatest integer function. What is domain and ranges of greatest integer function? So first I'll draw its graph. From that we can easily say what is its domain and range. You observe this greatest integer function. You see, these are like steps, stepping stones for success like that. So what is domain of greatest integer function? This is defined for all real numbers. Greatest integer function domain is all real numbers. I'll write that. Greatest integer function domain is all real numbers. What about its range? Here what I'll do, I know that range of greatest integer function is all integers. For example, step 0.5. Step 0.5 is what? Is 0. You observe step 0.5 is 0. Step x is giving 0. Step 1.92. Step 1.92 is what? Step 1.92 is 1. It is giving an integer. Step minus 0.5. Step minus 0.5 is what? Minus 1. So this greatest integer function always gives integers that you can observe from the graph also. Right? So the range of greatest integer function is what? The range of greatest integer function is all integers. So the range of greatest integer function is all integers. I hope you are understanding. Now you observe this. This is fractional part function. Fractional part of x. Fractional part of x is nothing but x minus step x. What is domain and ranges of fractional part of x? This is also standard function. You need to memorize its graph. The graph of fractional part function will be like this. This is graph of fractional part function. You can observe this is defined on its entire real numbers. So the domain of fractional part function is all real numbers. What about range of fractional part function? You can observe this graph. This graph is always in between 0 and 1. The range of this function is closed 0 to open 1. 0 is included, 1 is not included. So by seeing the graph, I can say that the range of this function is closed interval 0 comma open interval 1. You observe this fifth function log x base a. What is domain of log x base a? While doing domain of a function, we learned that logarithm is defined for positive real numbers only. So domain of this function is open interval 0 to infinity. This is defined for positive real numbers only. The range of log x is all real numbers. The range of log x is all real numbers. If you observe the graph of log x base a, the graph will be like this. This is the graph of log x base a when base is greater than 1. So you can observe here, this graph is there in negative y-axis as well as in positive y-axis. So the range of this function is all real numbers. You need to memorize graphs of the standard functions. Now I am going to take another 5 functions. Based on their graphs, we will discuss their domain and range. You see this a power x. What is domain and ranges of a power x? Here I am considering when a is greater than 1. Okay, the graph of a power x will be like this. Whatever the graphs I am drawing, they are all rough graphs. Just to quickly remind how the graph of a power x looks. I said that domain we always write by observing the x-axis. You can observe this is defined for all real values of x. So domain of a power x is all real numbers. What is range of a power x? You can see this graph is there in first quadrant as well second quadrant only. So this is positive y-axis and a power x will never gives you 0. You can observe whatever x value you want you take. A is some constant which is greater than 1 here. Whatever real x value you take, this value never be 0. So what is the range of this function? Range of a power x is open interval 0 to infinity. Keep this point in your mind. Signum function. What is domain and ranges of signum function? We can write its domain and range very easily if we see its graph. This is a graph of signum function. By observing x-axis, you can say that its domain is all real numbers. This function is defined for all real numbers. Domain of signum function is all real numbers. So whenever x is positive, signum function gives its value is 1. Whenever x is negative, signum function value is minus 1. In the function it is defined that signum function of 0 is 0. It is defined. So what about range of signum function? Range of signum function is 0 possible, right? As per the definition. Whenever x is greater than 0, signum function of x is 1. Whenever x is less than 0, signum function of x is minus 1. So domain of signum function is all real numbers. Range of signum function is 0, minus 1, plus 1. Very simple. See here x, f of x equal to x. Identity function, f of x equal to x. What is domain and ranges of the function x? If you observe the graph of identity function, the graph of identity function will be like this. So this function is defined for all x values. So domain of identity function is what? Domain of identity function is all real numbers. What is range? How you will say the range? By seeing y-axis you can say what values this function gives. So whatever x value you take, f of x is x na, f of 1.5 is 1.5, f of 1 crore is 1 crore, like that. If the domain is all real numbers, range is also all real numbers. What is range? What values the function f of x gives, that is range of the function. So the range of x is all real numbers. You observe here f of x equal to 1 by x, reciprocal function. First I'll draw the graph of reciprocal function. The graph of reciprocal function like this. Whatever the graphs I am drawing here, they are all rough diagrams. Okay, what is domain of 1 by x? As it is in the form of f of x by g of x cannot be equal to 0. The domain of this function is all real numbers except 0. What about range of 1 by x? What values this 1 by x gives? You can observe this 1 by x will never gives you 0. 1 by x will never gives you 0. Please try to understand. 1 by what number is 0? 1 by infinity is 0, but infinity is not defined now. So what is the range of 1 by x? Range of 1 by x can be any real number except 0. 1 by x will never be 0. 1 by x will never be 0. So, reciprocal function 1 by x domain is what? All real numbers except 0. What is its range? Its range is all real numbers except 0. Please keep this point in your mind. You observe here I taken x divided by mod x. What is domain of x divided by mod x? As it is in the form of f of x divided by g of x, if the denominator is 0, this is not defined. So, here x cannot be equal to 0. If x is 0, this denominator is becoming 0, this function is not defined. So, what is domain of this function? Domain of this function is all real numbers except 0. What is the range of this function? When x is greater than 0, x divided by mod x is 1. I hope you are understanding. When x is less than 0, at that time, x divided by minus x is minus 1. So, what values this x divided by mod x will gives you? It gives you either 1 or minus 1. Whenever x greater than 0, x divided by mod x is 1. Whenever x less than 0, x divided by mod x is minus 1. So, this function gives plus 1, minus 1. So, the range of x divided by mod x is the set 1 comma minus 1. So, what we learn in this class? We took some standard functions to understand what is domain, what is range, and we just quickly recalled the graphs of standard functions. I hope this class is useful to you. You can overcome the confusion in this model only with the help of practice. Practice makes man perfect. In this class, we are going to do 6 problems on range of a function. I saw many students, they feel difficult while calculating range of a function. Actually, these problems are little complicated only. However, I am trying to keep all model-wise problems at one place. In this class, I am going to do these 6 problems. I'll find range of all 6 problems. You can observe they are of the form f of x divided by g of x. We always do problems from easy to difficult level. So whatever the problems I am doing today, they are little easier only. Once you got a grip that what pattern we are following to solve all these problems, then you can understand these things very easily. I strongly recommend you to watch at least first 3 problems without fail. You just observe first 3 problems. Then you will come to know what I am trying to say exactly. So, before going to start this video, please drop a like for this video. Without much delay, let's begin the class. You observe this question number 1. We need to calculate range of this function x minus 2 divided by 3 minus x. To calculate range of a function, we will do 2 things. First one, I'll calculate domain of a function. Second point, first I'll take given function f of x as y. Okay, after taking f of x as y, I'll write x in terms of y. I'll write x in terms of y. If I do 1 or 2 problems, you will come to know what is this x in terms of y. After writing x in terms of y, I'll check that for what values of y, x is defined. For what values of y, x is defined. This third step you can understand while doing the problems. Domain of this function. As this is in the form of f of x divided by g of x. If this g of x is 0, then this function is not defined. 3 minus x not equal to 0 means x cannot be equal to 3. So what is domain of this function? Domain of this function is all real numbers except 3. I already did 10 videos on how to calculate domain of a function. You please go through those 10 videos. To calculate range, what I'll do? First step, I'll take given function as y. Okay, let y equal to f of x. Okay, what is f of x? In the question only f of x is there, x minus 2 divided by 3 minus x. I take a given function as y. Now second step is what? Write x in terms of y. You simplify this and then write x in terms of y. How? You observe. You just cross multiply. What you will get? 3y minus xy equal to x minus 2. Now what I'll do? I'll take this minus xy to this side and this minus 2 to this side. My intention is I want to write x in terms of y. Okay, take this to this side. 3y plus 2 equal to x plus xy. Now what I'll do? In this, I'll take x common. 3y plus 2 equal to, I'll take x common here. If I take x common here, what you will get? 1 plus y into x. Now you observe here, I can easily write x in terms of y. What is x? X equal to, you take 1 plus y to this side, what you will get? X is 3y plus 2 divided by y plus 1. 1 plus y plus 1 both are same only. You observe here what happened? I written x in terms of y. Now second step also over. What is third step? For what values of y x is defined? For what values of y x is defined means I am trying to find domain of this. It is of the form f of x by g of x. Now this denominator cannot be equal to 0. Y plus 1 not equal to 0. Y plus 1 not equal to 0 means y cannot be equal to minus 1. If y equal to minus 1, see here minus 1 plus 1, this denominator is becoming 0. That means x is not defined. Please try to understand. Finding range of a function is nothing but finding the y values. Here if y is minus 1, x is not defined. One more important thing, x cannot be equal to 3. Now I'll just check here. For what values of y x is 3? In this, in place of x, you write 3. You write here 3 equal to, in place of x I written 3. 3y plus 2 divided by y plus 1. Okay. Now what I'll do, I'll simplify this. You simplify this, what you will get? 3y plus 3 equal to 3y plus 2. 3y will get cancelled. You are getting 3 equal to 2. 3 equal to 2. It is not possible. That means it is not possible that whatever y value you take, x will never be 3. That means this expression will never gives you the value of 3. There is no chance that this expression equal to 3. So nothing to worry. What you got here? What is the domain of this? Domain of this is all real numbers except minus 1. So range is what? Range is all real numbers except minus 1. Have patience, try to understand at least 2 to 3 problems, then you will get clear idea what I am saying. This range of a function problems are little complicated only, but you can overcome this complication only with the practice. That is the only solution. You observe this question number 2, range of function 1 by x. Same procedure. First I will calculate domain. What is domain of this function? What is domain of this function? As it is in the form of f of x divided by g of x, the denominator cannot be equal to 0. X cannot be equal to 0. If x is 0, the function is not defined. That's why domain of this function is what? Domain of this function is all real numbers except 0. This is clear. So I calculated domain. Now to calculate the range, I'll follow these 3 steps. Step 1. You take given function as y. Okay, you take given function as y. You take f of x is y. Y equal to, what is f of x? F of x is 1 by x. What is the second step here? Write x in terms of y. Write x in terms of y. It is very simple. X equal to 1 by y. After writing this, what to check? What to check? For what values of y x is defined? For what values of y x is defined? X is defined means I am just trying to find domain of this part. It is very simple. As it is in the form of f of x divided by g of x, this denominator cannot be equal to 0. So what I say here, y cannot be equal to 0. And one more thing, here what is the domain of this function? R minus 0. Na? Domain means x values. X value cannot be equal to 0. Is it possible? You just check roughly here. Is it possible that 1 by y is 0? 1 by any number never be 0. 1 by infinity is 0, but infinity is not defined. No, this case is not possible. Okay. So here, what about range of this function? For what values of y x is defined? This is defined for all real numbers except 0. So what is range? Range of this function is all real numbers except 0. That's why domain of 1 by x is r minus 0. Range of 1 by x also r minus 0. I hope you understand this. Please stay with me. If you understand at least 3 problems in this class, then you can understand all the problems in this class. You observe this question number 3, range of f of x equal to x square minus 9 divided by x minus 3. To calculate range of this function, I am going to do 2 things. First, I will calculate domain of this function. What is domain of this function? As you know that given function is of the form f of x divided by g of x. This g of x cannot be equal to 0. That means x minus 3 not equal to 0. That means x is not equal to 3. So what is domain of this function? Domain of this function is all real numbers except 3. Once you calculated domain, now come to the range. How you will calculate range? To calculate range, I will follow these 3 steps. First step, you take given function as y. Let y equal to f of x. You take given function as y. What is f of x? F of x is x square minus 9 divided by x minus 3. You written given function as y. Now what you will do? You write x in terms of y. You write x in terms of y. Okay. To write x in terms of y, I will do little bit of simplification here. You see x square minus 9 is there. Now 9 can be written as 3 square. This is of the form a square minus b square. So what it will be? It will be x plus 3 into x minus 3 divided by x minus 3. This x minus 3 will get cancelled. What you will get? You will get y equal to x plus 3. What you are trying for? You are trying to write x in terms of y. What is x from this? X is y minus 3. You observe here, I written x in terms of y. Now, what you need to check? You need to check for what values of y x is defined. For what values of y x is defined. Here you take any real value of y, x is defined. You take any real y value, x is defined. I hope you are understanding. So, is the range of this function is all real numbers? No, no. Every time I am saying, you observe the domain. Domain is what? All real numbers except 3. That means x cannot be equal to 3. Is there any chance that this will give 3? I am checking. Is there any chance that this will give x 3? I am checking here. In place of x, I written 3. 3 equal to y minus 3. Y equal to 6. You observe, when y is 6, x is 3. You observe, when you write y is 6, if you write y is 6, 6 minus 3 is 3, x is 3. If x is 3, this function is not defined. I hope you are getting the point. Don't take this part lightly. This part is also important. So what I need to write? What is range of this function? For all real numbers, for all real values of y, x is defined, even though when y is 6, function is not defined. That's why range of this function is all real numbers except 6. This is very good example to understand range of a function. Everything you need to consider. You cannot take few things lightly. So, range of this function is what? All real numbers except 6. I hope you understand this. You observe question number 4. We need to calculate range of the function f of x equal to 4 minus x divided by x minus 4. It is interesting problem. First, what I'll do? I'll calculate domain of this function. What is domain of this function? As given function is in the form of f of x divided by g of x, this denominator cannot be equal to 0. X minus 4 not equal to 0 means x cannot be equal to 4. So what is its domain? Its domain is all real numbers except 4. Now it comes to range. General procedure we can follow. But I can follow this general procedure. But you observe here, this f of x, simple thing. You observe here, f of x is given as 4 minus x divided by x minus 4. Now you take minus common in the numerator. If I take minus common in the numerator, it is nothing but minus of x minus 4. Minus of x minus 4 means 4 minus x only, divided by x minus 4. This x minus 4 will get cancelled. What you are getting? F of x is minus 1. It tells you what? Whatever real x value you take other than 4, when you take x is 4, this function is not defined. You take any real x value other than 4, this function always gives minus 1. It is simple thing. Suppose in place of x you take 6. 4 minus 6 is what? Minus 2 divided by 6 minus 4 is 2. Minus 2 divided by 2 is minus 1. Whatever real x value you take other than 4, it always gives minus 1. So no need of this procedure for this. This is a special type of problem. So what is the range of this function? Whatever real x value you take other than 4, it always gives minus 1. So therefore range of this function is singleton set minus 1. I hope you understand this. You observe this question number 5. Range of f of x equal to ax plus b divided by bx minus a. I want to calculate range of this function. First I will calculate its domain. How to calculate its domain? You can observe whatever the problems we are doing today, all are of the form f of x by g of x. So this denominator part cannot be equal to 0. Bx minus a cannot be equal to 0. This means bx cannot be equal to a. Take minus a to that side. That means x cannot be equal to a by b. So what is domain of this function? Domain of this function is all real numbers except the values of a by b. If I take in place of x, if I write a by b, bb will get cancelled. A minus a, denominator is becoming 0. So domain of this function is all real numbers except the x values of the form a by b. Now I need to calculate the range. To calculate the range, I'll go with these three procedures. What is the first step? I'll take given function as y. Y equal to f of x. Y equal to, what is f of x? F of x is ax plus b divided by bx minus a. What I'll do now? I'll write x in terms of y. You simplify this little bit and write x in terms of y. You just cross multiply. What you will get? byx minus ay equal to ax plus b. This plus ax, you take this side, what you will get? byx minus ax equal to b plus, you take minus ay to the right hand side, b plus ay. What I need? I need x in terms of y. You take x common here. If I take x common, what you will get? by minus a. So b plus ay divided by by minus a. You can understand this. I just taken x common here. By minus a is there, that taken to the denominator. So what happened? You observe here, x completely in terms of y. I written x in terms of y. Now what is the next step? For what values of y x is defined? For what values of y x is defined? That means I am just trying for domain of this part. Right? As it is in the form of f of x divided by g of x, this denominator cannot be equal to 0. So by minus a cannot be equal to 0. So if I simplify this, by is not equal to a, y is not equal to a by b. So this is defined for all real numbers except when y is a by b. So what I can write here? I can write that range is all real numbers except the values of a by b. This is the range actually. One more thing we always consider. Here x cannot be a by b. Is it possible that x is a by b? I'll write this and I'll check it. In place of x, you write a by b. A by b equal to b plus ay divided by by minus a. Now you just simplify it and you check for what values of y x is a by b. Cross multiply, what you will get? Aby minus a square equal to b square plus aby. So here aby will get cancelled. You are getting minus a square equal to b square. This is not possible. That means whatever the y value you take here, x will never be a by b. So it's okay, no problem with this case. So what values of y x is defined here? It is defined for all real numbers except the values of y in the form of a by b. So range of this function is all real numbers except a by b. I hope you are understanding. Try to get this pattern. In what pattern we are doing all the problems, you try to get that pattern. You observe this question number 6. Range of f of x equal to 1 divided by x minus 7. So two things I will do. First I will calculate domain. Tell the domain of this function. Can you answer quickly what is the domain of this function? Yes, domain of this function. Denominator cannot be equal to 0. That means x minus 7 not equal to 0. That means x not equal to 7. So domain of this function is all real numbers except 7. Okay. Now range. To calculate range, I'll follow this method. First, I'll take given function as y. Okay. Let y equal to f of x. What is f of x here? F of x is 1 divided by x minus 7. Now what I'll do? I'll write x in terms of y. To write x in terms of y, I'll simplify this. Cross multiply, what you will get? xy minus 7y equal to 1. What I need? I want x in terms of y. Now you take 7y to that side. xy equal to 1 plus 7y. What is x from this? 1 plus 7y divided by y. Now what you need to check? For what values of y x is defined? That you check. For what values of y x is defined? You check. It is nothing but calculating domain of this part. It is of the form f of x by g of x. Now this denominator part cannot be equal to 0. So y not equal to 0. So what is range? I will write here. I will write that range is all real numbers except 0. This is the range of the function. But always keep in your mind, what is domain of this function? R minus singleton set 7. Here x value cannot be equal to 7. You check in the margin that is it possible that for what values of y x we will get 7. In place of x you write 7. 7 equal to 1 plus 7y divided by y. You cross multiply, what you will get? 7y equal to 1 plus 7y. 7y will get cancelled. You will get 1 equal to 0. This is not possible. This is not possible. That means whatever the y value you take, x will never be 7. I hope you are getting the point. So for what values of y x is defined here? This is defined for all real numbers except 0. Therefore range of this function is all real numbers except 0. Dear friends, we always do from easy to difficult level. In this class, I did 6 problems, all 6 problems of easy level only. In this class, what you need to learn, try to get the pattern, in what pattern we are using to find the range of a function. First, I calculated domain, I kept it aside, and then I am following these 3 steps, right? In next class, we will come with little more difficult problems. You can observe all these are rational functions. They are all of the form f of x by g of x. And you can observe that in each function, x square term is there. So this type of problems comes under one type. Whatever the problems we are doing today, they are little tougher compared to earlier class. You please go through last 6 problems. Then you can understand these 6 problems very easily. That 6 problems video link I will give in cards. Please find that link in cards. In last class, we understand the pattern, in what pattern we will do to calculate range of a function. What is that? We will do 2 things. First, I will calculate domain of a function. Second, to calculate range of the function, I will follow these 3 steps. What are those 3 steps? First, I will take given function f of x as y. After taking given function f of x as y, by simplifying, I will write x in terms of y. Write x in terms of y. This you can understand while doing the problems. I will write x completely in terms of y. Now third one, for what values of y x is defined? You check that for what values of y x is defined, that will be the range of the function. This you can understand when the problem is going on. So before going to start this class, please drop a like for this video. Without much delay, let's begin the class. You observe this question number 7. We need to find range of the function f of x equal to x divided by 1 plus x square. To calculate range of a function, we will do 2 things. First, I will calculate domain of the function. Second one, we will follow these 3 steps. First, I will take given function f of x as y, and then by simplifying, I'll get x in terms of y, and finally I'll check for what values of y x is defined. First, I want to calculate domain of this function. As it is in the form of f of x divided by g of x, this g of x cannot be equal to 0. You can observe here, this is 1 plus x square. This 1 plus x square will never be 0 because this minimum value is 1. So whatever real value you take, whatever real x you take in the denominator, this denominator is not going to be 0. So domain of this function is all real numbers. Now to calculate range, I will follow these 3 things. Step 1, you take given function f of x as y. Okay, let you take given function f of x as y. What is f of x? They given in the question, f of x is x divided by 1 plus x square. Okay. Second step is what? Write x in terms of y. To write x in terms of y, I need to do a little bit of simplification here. Cross multiply, what you will get? You will get like this. Y into x square plus y. You just cross multiply, you will get this. Here, a little tricky thing is there. What you want? You want x in terms of y. To write x in terms of y, here x square is also there, x term is also there. Observe this clearly, what is going to happen. I'll write like this, y into x square, you take x to this side plus x to this side, it will become minus x. Minus x is nothing but minus 1 into x plus y equal to 0. If you observe this, this is quadratic equation in x. You observe x square term is there, x term is there. So, by using minus b plus or minus root over b square minus 4a by 2a formula, I can calculate x here. So, to calculate x, I'll use that formula. X is minus b. Here minus of minus 1, that is plus 1. Minus b plus or minus root over b square. B square means minus 1 whole square. Minus 1 whole square is 1 only. B square minus 4 AC. A is y, C is also y. AC, y into y is y square divided by 2a. A means this one, 2y. I hope you understand. This is quadratic equation in x. To find x value, I used minus b plus or minus root over b square minus 4ac by 2a formula. Now you observe here, I got x completely in terms of y. See, this side x is not there. This is completely in terms of y. What happened? I written x in terms of y. Second step is over. What is third step? For what values of y x is defined? That means you are trying to calculate domain of this part. For what values of y x is defined? X is defined means when this is defined. When this is defined means I am calculating domain of this function. Okay, you already learned how to calculate domain of the function. Now I'll calculate domain of this part. First thing, this is of the form f of x by g of x na. This denominator cannot be equal to 0. That means what is denominator? 2y. 2y cannot be equal to 0. That means y cannot be equal to 0. Second one, in this you observe square root is there. So we know that whatever the expression is there inside the square root, that must be greater than or equal to 0. So what I'll write here? I'll write that 1 minus 4y square is greater than or equal to 0. Now I need to find for what y values this inequality holds good. What I'll do, this complete inequality I'll multiply with minus. Then what happened? This will become 4y square minus 1. You know that for an inequality, if we multiply with a negative real number, inequality sign changes. Here this greater than or equal to changes to less than or equal to. Less than or equal to minus 0 is nothing but 0 only. I hope you all understanding. To calculate y values which satisfies this inequality, I want to write this in the form of y minus a into y minus b. To get into that form, I'll take 4 common. Take 4 common, what you will get? Y square minus 1 by 4 less than or equal to 0. I hope you are understanding. As 4 is a positive number, both sides you divide with 4, inequality remains same. This 4 will get cancelled. This y square minus 1 by 4 is there. Na? This 1 by 4 can be written as 1 by 2 whole square. Na? Y square minus 1 by 2 whole square. This is of the form a square minus b square. So this can be written as y plus 1 by 2 into y minus 1 by 2 less than or equal to 0. Okay, now you observe it is in the form of y minus a into y minus b. By using wavy curve method, I can easily calculate for what values of y this inequality holds good. So mark them on the number line as per number line order. You equate this to 0, you will get y is minus 1 by 2. So minus 1 by 2 first. Equate this to 0, you will get y equal to 1 by 2. Okay, in the rightmost corner plus and then alternate symbols minus plus like this you write. Okay, now here less than 0 is there na? Less than 0 means negative sign. So I want this part. So y belongs to closed interval minus 1 by 2 comma 1 by 2. When y value is in this interval, at that time this inequality holds good. See, what is the domain of this function? The values which satisfies both the conditions. See here, this is the first one. Y cannot be equal to 0 and y must lies in this interval. Now I need intersection of these two. In this interval 0 is there? Yes, but y cannot be 0 na? So what is the range? Range is closed interval minus 1 by 2 comma 1 by 2 except 0. In this interval 0 is there na? I removed that 0. I hope you understand. So range of this function is what? Closed interval minus 1 by 2 comma 1 by 2 except 0. See, these problems are easy only. Please stay with me. Try to understand what is happening. Okay. You observe this question number 8. We need to calculate range of f of x equal to 1 divided by 1 minus x square. To calculate range of this function, we will do two things. First, I will calculate domain of this function. As it is in the form of f of x divided by g of x, na, the denominator cannot be equal to 0. That means 1 minus x square not equal to 0. 1 minus x square not equal to 0 means x square is not equal to 1. If x square is not equal to 1 means x is not equal to plus or minus 1. If x is plus 1, denominator is becoming 0. If x is minus 1, then denominator is becoming 0. So I need to remove these values from the domain. So what is the domain of this function? Domain of this function is all real numbers except plus 1, minus 1. Now I need to calculate range. To calculate range, I'll follow these three steps. First, I'll take given function f of x as y. Let y equal to f of x. Okay, y equal to f of x. What is f of x? In the question only given that f of x is 1 divided by 1 minus x square. Now what is second step? I'll write x in terms of y. I'll write x in terms of y. Okay, to write x in terms of y, I'll cross multiply. Cross multiply, what you will get? Y minus y into x square equal to 1. What you want? You want x in terms of y na? So what I'll do? I'll take this term to the right hand side. Then what you will get? You will get that y minus 1 equal to x square y. Okay, from this what is x square? From this x square is y minus 1 divided by y. What I want x in terms of y. You apply square root on both sides. What you can write here? X equal to plus or minus square root of y minus 1 divided by y. I hope you are understanding. What happened here? I written x in terms of y. You can observe, I written x in terms of y. So here second step is over. I written x in terms of y. Third step is what? For what values of y x is defined? For what values of y x is defined means I am trying to find domain of this. For what values of y this is defined? This is nothing but x. I hope you are understanding. Now what I need to do? I need to calculate domain of this part. As this expression is in under root, now whatever the expression is there in under root, that must be greater than or equal to 0. So y minus 1 divided by y will be greater than or equal to 0. And it is in the form of f of x by g of x. Now this denominator cannot be equal to 0 and y cannot be equal to 0. Now you need to find the y values which satisfies both the inequalities. You observe here this y is there. Now y can be written as y minus 0 now. Y can be written as y minus 0. Why I written like this? If it is in the form of y minus a divided by y minus b, I can easily calculate y values by using wavy curve method. You equate this to 0, y minus 1 equal to 0 means y is 1. Okay, mark them as per number line order. You equate this to 0, y is 0. Now in the rightmost corner you write plus and alternate symbols, minus, plus. Now greater than 0 means which sign you want? You want positive sign. So what are the y values you will get here? Y belongs to positive sign. Now positive sign means what you will get? Minus infinity to, here equality is there. Equality is there. I'll include that. Closed 0, union. Positive sign I want now. Closed interval 1 to open interval infinity. So these are the y values satisfies this part. Now what I need combination of these two. Here y cannot be equal to 0. In this y equal to 0 is there. In this interval 0 is there. Yes. Closed 0 means 0 is included now. But y cannot be 0. So what about range? Range is open interval minus infinity to open interval 0. Open interval 0 means 0 is not included because y cannot be equal to 0. Union closed interval 1 to infinity. And one more thing you need to consider, x value cannot be 1, x value cannot be minus 1 because those values are not in its domain. Is it possible that x value plus or minus 1? I'll check here. In this equation, in place of x, I written plus or minus 1. Okay, equal to plus or minus root over y minus 1 divided by y. You square this on both sides, what you will get? 1 equal to y minus 1 divided by y. Okay, now you cross multiply, what you will get? Y equal to y minus 1. Y will get cancelled, you will get 0 equal to minus 1. That means what? It is not possible. That means whatever y value you take, x will never be plus or minus 1. So nothing to worry about this point. Nothing to worry about this point. In last class I said that sometimes this changes the range. So you need to consider this point also. Okay. So finally what is the range of this function? Range of this function is open interval minus infinity to 0 union closed interval 1 comma open interval infinity. You observe this question number 9. Range of the function f of x equal to x square divided by x square plus 1. To calculate range of the function, first we will calculate domain. This is in the form of f of x divided by g of x. Now, this g of x cannot be equal to 0. Here x square plus 1 is there. Now, whatever real x you take, x square plus 1 will never be 0 because minimum value of x square is 0. Whatever real x you take, minimum value of x square is 0. So, this minimum value is 1. This will never be 0. So, what is the domain of this function? This function is defined for all real numbers. So, domain of this function is all real numbers. Now, I need to calculate range. To calculate range, I will follow these 3 steps. First step is what? You take given function f of x as y. You take given function f of x as y. So, what is f of x? In the question they given that f of x is x square divided by x square plus 1. Now, what I need, second step, I want to write x in terms of y. To write x in terms of y, what I'll do, I'll simplify this. Simplify, what you will get? Y into x square plus y equal to x square. What we want x in terms of y. Na? You take x square to this side and take x square common. What you will get? Y minus 1 into x square equal to minus y. I hope you understand. Now what I need x in terms of y. What is x square from this? X square is minus y divided by y minus 1. Here minus is there. Now what I'll do? Numerator, denominator, I'll multiply with minus. So what I'll get? I'll get that x square equal to y divided by 1 minus y. Now what I need? I want x in terms of y. So for that I'll apply square root on both sides. What you will get? X equal to, apply square root on both sides, x equal to plus or minus root over y divided by 1 minus y. Second step is over. I written x completely in terms of y. Second step is over. What is third step? For what values of y x is defined. That means for what values of y x is defined. Now I need to find domain of this. You know how to calculate the domain of the function. Whatever the expression is there in under root, that must be greater than or equal to 0. That means y divided by 1 minus y must be greater than or equal to 0. And one more thing, this is of the form f of x by g of x. This denominator cannot be equal to 0. So 1 minus y cannot be equal to 0. That means y cannot be equal to 1. Now, to find for what values of y this inequality holds good, I need this in the form of y minus a divided by y minus b. Here this is not in the form of y minus b. This inequality I will multiply with minus on both sides. If I multiply with minus on both sides, what it will become? Y divided by this 1 minus y will changes to y minus 1. I hope you are understanding. For an inequality, if you multiply with a negative real number, inequality sign changes. This greater than or equal to changes to less than or equal to 0. If it is in the form of y minus a divided by y minus b, by using wavy curve method, I can easily say for what values of y this inequality holds good. So here this y I can write y minus 0. Y minus 0 is same as y only. You mark these numbers on the number line. Now equate this to 0, you will get 0. Equate this to 0, you will get 1 in the rightmost corner. Plus and then alternate symbols. Now less than 0 means negative sign. So I want these values. So y belongs to less than or equal to 0 is there. That's why closed interval 0 comma 1. I need to consider this one also. Here y cannot be equal to 1 is there. In this interval 1 is there. Here closed interval is there. So I need to remove it. So what is the range of this function? Range of this function is closed 0, open 1. 1 is not included because y cannot be equal to 1. Therefore, the range of this function is closed 0, open 1. I hope you are understanding. Try to get the pattern. In what pattern we are doing all these problems. You observe 10th question. Range of the function f of x equal to 3 divided by 2 minus x square. To calculate range of this function, we will do two things. First, we will calculate domain. What is domain of this function? Given function is in the form of f of x divided by g of x. This denominator cannot be equal to 0. That means 2 minus x square cannot be equal to 0. That means x square cannot be equal to 2. Apply square root on both sides. That means x cannot be equal to plus or minus root 2. So if x is plus root 2, then this denominator is becoming 0. If x is minus root 2, then also this denominator is becoming 0. Then this function is not defined. That's why we need to remove those values from real numbers. So what is the domain of this function? Domain of this function is all real numbers except the values of root 2 minus root 2. This is the domain of the function. Now I need to calculate range. To calculate range, I will follow these three steps. First step is what? First you take given function f of x as y. What is f of x? In the question they given that f of x is 3 divided by 2 minus x square. So I take in given function f of x as y. First step is over. What is second step? I want x in terms of y. I want x in terms of y. To write x in terms of y, I will do little bit of simplification. You cross multiply. What you will get? You will get 2y minus x square y equal to 3. What you want? You want x in terms of y. So what I will do? I will take this to other side. Then 2y minus 3 equal to x square y. As I want x in terms of y, I will take y to this side. Then what you will get here? X square is 2y minus 3 divided by y. You want x na, here x square is there. You apply square root on both sides, then what you will get? X equal to plus or minus square root of 2y minus 3 divided by y. X equal to, you got like this. You observe, I written x completely in terms of y. You see, x in terms of y. Second step is over. I written x completely in terms of y. What is third step? For what values of y x is defined? For what values of y x is defined means we need to calculate domain of x. X is nothing but this na, that means I need to calculate domain of this. You know already how to calculate domain of a function. As this expression is under root, whatever expression is there inside the root, that must be greater than or equal to 0. So 2y minus 3 divided by y, this must be greater than or equal to 0. It is of the form f of x by g of x na, this denominator cannot be equal to 0. And y cannot be equal to 0. Now, to get the y values which satisfies this inequality, if it is in the form of y minus a divided by y minus b, by using wavy curve method, I can say easily. But here, this is the y coefficient 2 is there. I want y coefficient 1. So, I'll take 2 common here. If you take 2 common, what you will get? Y minus 3 by 2 divided by, this y can be written as y minus 0 greater than or equal to 0. As 2 is positive, You divide both sides with 2. This 2 will get cancelled. 0 by 2 is 0 only. I hope you are understanding. Now this is in the form of y minus a divided by y minus b. To get the y values which satisfies this inequality, I'll use wavy curve method. Equate this to 0. What you will get? Y equal to 3 by 2. 3 by 2 means 1.5 something. So I written here 3 by 2. You equate this to 0. You will get y equal to 0. You mark them as per number line order. What next? Rightmost corner plus and then alternate symbols. Here greater than 0 is there. Greater than 0 means this positive sign I want. So what are the y values which satisfies this inequality? Open interval minus infinity to, here equality is there na, closed 0 union closed interval 3 by 2 to infinity. Why I written closed brackets? Because here greater than or equal to is there. I need to consider this also. Y cannot be equal to 0. In this interval 0 is there. Here closed 0 is there na? Closed 0 is there means 0 is included. But y cannot be 0 na? So what about range? I need to remove 0, right? What about range of this function? Range of this function is open interval minus infinity to open 0. Open 0 means 0 is not included. Union closed 3 by 2 to infinity. This is range of this function. I hope you understand this. You can observe last class whatever the 6 problems I did, they are all of one type. And you can observe today what problems I did, they are little similar to previous class, but small change is there. Try to understand what pattern we are following to find range of the given function. I hope you understand this class.